Okay. How's it look, Greg?
Looks good.
Okay. Welcome, everybody. Welcome to the CURT Offsite Construction Modularization Summit event. It's great seeing a lot of familiar names and faces on the screen. And throughout the day, if you could share your face so people can get to know you, that's an important part of networking in this type of environment that we're living in today. Today is the roadmap to success. It's on offsite construction and modularization, which is picking up so much steam in today's environment that we're dealing with. We have a fantastic lineup of speakers, topics, and focus areas. We have our co-chairs, our new co-chair, Badar. We're wishing the best to Mike Brewer upon his future semi-retirement, I'll call it for now, or at least his next endeavor. And then we have a great lineup of speakers from a lot of corporate companies. And also we have Andy from ModSmart working with a Yingo Yang from Dow. And I apologize, Andy, but I could not switch the picture on this screen, but I want to acknowledge ModSmart Company and Andy Yee on that. Your voice matters today. So success for today means a lot of things. It means you have direct access to our speakers' bios, photos, and today's presentation. So everything that you're going to see here today is being recorded, as well as you'll have direct access already through the CURT app for all the background information as you choose to take notes or not. You have the opportunity to ask questions. We ask that you use Zoom chat box. I'll capture the questions during each of the speakers. I'll prompt them back as the moderator to those speakers, stating your name and company and that. So if you are showing up as unknown, if you could provide your name and company, that would be helpful in the title as you logged in. We would like you to share your values too, or learnings that you're seeing as we cover the various topics across the board. And that drives a lot of success in the networking that we're trying to do virtually here, or at least the face. Again, we have a great lineup this time, and a lot of diverse speakers, backgrounds, from the professionals to the owners to the contractors to the trade partners to the service providers and everybody that's on board today. And each of you bringing all the years of experience and expertise that you have on the table. We're going to hear from FMI Corporation on the outcome of their industry owner survey. It's about the third or fourth survey that FMI has conducted for us, both on the owner side and the contractor side. And it's a lot of great data that we're starting to see in today's work. We're going to journey to the north to Canada with us to see how the Construction Owners Association of Alberta, Canada is forming their module assembly best practices under these conditions. And we're going to have more time for questions and discussions with these morning topics. Moving into the afternoon as we blast off, we're going to launch into topics such as cost priorities and can it continue to drive the business decisions. We're going to see how Wyson Engineering has conducted project comparisons between stick-built and modular. This is always a topic of being asked.
Yeah, I do. I'm getting audio.
Okay. Cost priorities, and we're going to see how this discusses the advantages that modular brings to the industry. We're going to talk about the modular drive of quality assurance and control and what the differences are with modularization. We're going to consider early design and center of gravity weight and balance planning. We're going to hear about a case study demonstrating what module weight and center of gravity are going to impact the module things with Andy. We're going to talk in preparation for this afternoon. One of the things I'd like you to think about right now, we have a panel set with our co-chairs, and that's William, Badar, and Michael. And we have Steve Leyu from Comores as well. And we're going to ask you to submit your questions throughout the day addressing this question of the subject of COVID and the factors around the world. What's influencing modularization business strategies in that in your company? And what do you want to hear from these panel members on that? So submit your questions on that. We'll use those as a driving start for the afternoon panel. And we'll continue to build and network on that for time in the mid-afternoon section to do that. And we have a lot more throughout the day. So without further ado, I'd like to go ahead and kick off to our guest keynote speakers from FMI Company, Sabine Hoover, director, content director, and Chris Brizardo, FMI consultant, who've pulled this survey together and worked for the forecast and trends analysis update. Sabine, I'd like to turn it over to you and Chris at this time. If you can request share, and I'll stop sharing. We'll go from there.
Great. Thank you, Joe. Chris is going to share his screen.
Okay.
Oops.
Let's share the right one. How's that?
It's come up. I see it.
Perfect. All right. Well, welcome everyone, and hello everyone. Good to sort of see and hear everyone in this new setting, I guess. Here we are, 2020, right? Just as a reminder, for those of you who aren't aware of some of the research that we've been doing, this is actually the third survey we've done for CURT. We started out back in 2017 with a prefabrication survey focused primarily on contractors, engineering firms, and then we also did an owner survey back in 2017. And today what we're going to show you are the results of another owner survey that we conducted back in April. And so we'll be comparing and contrasting the results from 2017 and 2020. And while many of the themes are very similar, there are definitely some changes and nuances that are happening in this world of offsite construction. So let's go to the next slide. Just want to kick off this presentation with a quote that is hopeful, and sometimes, you know, when we're in this world of craziness, and also you guys are, many of you are on these impossibly complex projects, you know, working with people all around the world, and sometimes it's things, you know, you're not making any progress or still doing the same things the same way. But I think, you know, at the end of the day, we all have a little bit of power in changing and making a difference, and progress is happening. And you'll see that from some of our results, even though there's still lots of room for improvement. Things are changing, and you are all involved in making that change around offsite construction for sure. So I'll start with a quick overview of our findings. For one, change is happening, and while, you know, we looked at the data from 2017 and 2020, and in speaking with some of you also, change is happening, but it's maybe not happening as quickly as you would like. And that is also reflected in some of the data. Practice makes perfect. You're getting better offsite construction. Many owners are doing more of it today, and the results are better than they were back in 2017.
Oh, cool.
Someone needs to go on mute. All right, thank you. And then minding the gap, that's really sort of a highlight on some of the areas that still need a little bit more work, and we'll go into more detail around that, specifically around how these projects are planned out with all the different stakeholders and executed in a more strategic way. And then finally, the people factor. As we know, you know, people they like their habits, they like the way they do things, and we just are slow to adapt and change sometimes. And it shows in some of the innovation and progress that's being pushed. That culture oftentimes is one of the main stumbling blocks. So that said, let's hop right in. Oh yeah, a couple of study facts, just so you know the context of the data, which is always very important. So we surveyed owners from CURT and CII, 65 responses, a little lower than last time, but still a good sample size for this group. Mostly industrial, petrochemical, oil and gas, power generation, manufacturing, no surprises there. And many of you are working for very large companies, not surprisingly, billion-dollar plus. So the projects that we're talking about are mega projects, and many of them do have that offsite construction component. All right, so we'll start with our first topic, and we're going to make you work. We have a little question, 2 questions for you, and I want you to use the polling tool, and we'll get right started with this first question. Is today's offsite construction environment different compared to 3 years ago? Yes, no, unsure, and we'll start with that one. Let's see where that takes us.
All right, we got about 6 responses. Keep them coming.
All right.
Mine's not working, so if it doesn't start working, maybe you can send it again. The polling tool, can you send it back up?
Sure. I can't end it right at the moment, but it looks like click on your polls and see if it might have popped up somewhere else on one of your monitors, Bill.
Okay. Let me
So
see.
I'd take a look around. You might be able to find it because I don't want to end it quite yet because we're getting more answers coming in.
Okay. It's probably just me. Thank you.
No, it's all good.
See the summaries? Do you just click on the line with the bar that says yes, or?
Yeah, you should just be able to select yes, no, or unsure. And we have 2 questions. We're only going to speak to the first one now, and then the second question I'll bring up again a little later in the presentation.
Okay.
Very quickly, it worked very well. Rob.
What was that?
I said it worked very well. It popped up in the middle of my screen. I answered it. It was like 20 seconds worth of work to do. So it worked beautifully.
Perfect.
Good stuff.
All right, we'll give
I'll
it a
wrap
few
it
more
up.
seconds and then we'll move on.
All right, I'm going to wrap this
Yep, wrap it up.
and
Okay.
I'll share the results.
Perfect. All right, so this matches beautifully with what we looked at. So 57%, almost 2/3 of you think offsite construction environment is different than 3 years ago. 13% no, and about 30% unsure. That's interesting. So let's go to the survey data. Can you close the polls? Sorry, I'm going to close that. Okay. So this is what we got in this year's survey. Look at the top line numbers. The numbers grayed out were what we collected back in 2017. So very similar to what we just polled you on now. 60% say yes, the industry is different in terms of offsite construction environment, but 25% no, and 14% unsure. And this was confirmed in some of the interviews I conducted and the notes that you submitted. Much of this is driven by technology, obviously, the use of technology, the evolution of technology. There are also more companies that are able to do this now, like on the construction side where FMI deals a lot with large construction firms. We're seeing bigger firms getting bigger. They're having the resources to do offsite construction, do a lot of research and development. And this is being reflected again in this environment and how quickly it's changing. The next quote on the next slide, this was from one of the study participants, and it's really sort of shows how, you know, people are getting more open to this. Even though 3 years ago, many, you know, of you said that offsite construction is very popular, I would guess that today, even more people are saying they're involved in it, they're trying new things, there's a greater willingness to try new techniques because the market has been so hot up until now. Now that said, with COVID, we're going to see what happens. Also with all the geopolitical things going on, that might also put a whole new dynamic on this world. Going to the next slide. So what are some of the top reasons for this changing offsite construction environment, like I mentioned? And what's interesting, you know, compared to when we did the study in 2017, back then labor shortage was really the top reason that was, you know, driving offsite construction. But now it's really project costs and schedules. And that's also not surprising. Over the last few years, you know, we've seen an incredible boom in the design and construction environment. Speed to market has been key for owners to get things built quickly. and hence also the push towards bundling smaller projects into bigger projects, offsite construction, looking at all the different ways that project schedules and costs could be reduced. So we're seeing that reflected in this data. Let's go to the next. The positive thing is that while the environment is changing, there are more partners, the industry as a whole is getting better at doing this. And that was really encouraging to see. So again, back in 2017, we asked people, how effective is your organization doing offsite construction? And we had the different methods: prefabrication, modularization, pre-assembly, multi-trade. And you can see the grayed out numbers, which represent the 2017 numbers and 2020. So even though the differences don't seem huge, this is progress. And, you know, kudos to all of you for working on improving things, streamlining things better, trying to collaborate more tightly with your partners. This is a direct result of that. And I think this is really something to be proud of. The next slide also shows us how much more it's being used. And this is also encouraging to see. Prefabrication is almost done on 60% projects, 52% for modularization. And so these are numbers that show me that, you know, again, everybody's doing more of it, trying to reduce the cost and schedules of these projects. And the industry is getting better. And I think I mentioned this back in my presentation in 2018, success breeds success. And this is exactly what this is. We are sharing case studies, we're sharing best practices of what works, what doesn't work. And the results, you know, are positive and are trending in the right direction. Go to the next one. So again, main drivers for adopting offsite construction this year, mostly capital cost effectiveness. So the whole capital cost is something that is a big one in this whole discussion. Back in 2017, it was more around project location, project type, but now it's really down to the money and schedule and getting also people, because there is still a shortage in many cases of skilled labor, and this offsite construction is definitely a way of circumventing that. Let's get to the next. Great. So I'm going to hand this over to Chris, and off you go.
All right. Well, I'm going to bring back up the polls because the second question, let me share our results again. So everyone can see here, the second question we asked was, does your organization have a stated goal or strategic plan to perform a certain percentage of your capital project construction efforts offsite? And it looks like almost 50% of this group said no. And that's interesting. That kind of lines up with what we're seeing in the data as well. If I go to the next slide here, we, in our survey, found that almost 2/3 of participated survey respondents don't have a stated goal for their construction efforts offsite. And the good news is that that number has increased since 2017, right? In 2017, only 84% of, only 16% of respondents said that they have a stated goal or strategic plan. Now we're up to almost 30%. And the thing about having a stated goal or strategic plan is that when we see some of the best organizations, you know, who are adopting offsite construction faster, better, kind of beating out the competition right now, they have it as a strategic priority like this. So we wanted to really get the market's feel for, you know, who's doing this, who's not, and see if that result has improved since 2017. That being said, we know that this goal is never going to be 100%, you know, because you can't just throw in offsite to every single project you ever do. Some things are just meant to be stick built. But as I think as this industry continues to progress, we're going to see more and more strategic goals and just stated plans for the use of offsite construction. And if you look to the left side of the slide too, what goes hand in hand in that is organizations conducting feasibility analyses. again, as we see over here, 64%, almost 2/3 again of respondents said that they're not conducting feasibility analyses on the use of off-site construction. And what that tells us is that really these organizations need to kind of be conducting these more from the top. It needs to be kind of a strategic priority coming down from the top, because with more feasibility studies coming in, more thoughtful planning, it could lead to more adoption of off-site construction on the whole. But what we're seeing right now is that there's just not as many people as you would think that are strategically planning for it or conducting the analyses in order to get off-site really to the front of mind for everyone. So today it's really kind of not clear what the business case for off-site is. Well, it's clear what it is, but it's not being implemented as much as we would expect. And here's a quote from a survey participant that really resonated with some of our findings. Einstein's definition of insanity, just doing the same thing over and over again, expecting different results. That's kind of what we began to see in the data, was that while we're making steps, as Sabine pointed out too, and things are getting better and people are becoming more effective with offsite, we're kind of in this lull of doing the same things and just hoping for a different result. So I think as the industry moves forward and people begin to innovate more and really put it at the forefront of their organizations, I think this quote will change to a little different. There'll be a little different narrative from some of the survey respondents over the next few years, I think, if we can go in the right direction here. All right, and here we wanted to highlight the top challenges that you face, or that survey respondents faced in planning for offsite construction. So the top three here, and it was anywhere from 1/4 to 1/3 of respondents highlighted these. Developing a viable execution strategy, contractor selection, and procurement plans and vendor interfaces. And the main point here that we saw was that these top three challenges, they all have to do with internal and external stakeholders. You know, the problem that firms are seeing, the biggest challenges that people are facing, is bringing in the right people together at the right time. It's not really happening effectively right now. Firms need to bring in contractors earlier for the conversations to start up front for this business model. You know, you really need to get everyone in the room, all stakeholders, you know, and develop that viable execution strategy with them up front. And that's been one of the biggest challenges that our survey respondents seem to be facing right now. It's really about including people in the discussion, engineers, executives, leadership at your own company as the owner, contractors, you know, vendors, just anyone involved. It just takes a lot more planning up front than what's happening right now.
I just want to echo that. We've done some other research around mega projects that kind of echoes this whole theme of trying to build good teams up front. And one of the success ingredients that came out of our research around mega projects was really getting strong teams together at the beginning of the project, building the trust, the communication, the transparency, and then of course the right leaders. And we're talking about top leadership, because it can't just be the project execs. It's, you know, like with owners, it has to also be the business leaders who understand what's going on and how this is done. So it's also very much an educational process in setting up these projects successfully. And once that's done, you have sort of the groundwork for running these projects. But oftentimes people don't put enough time in building that trust, putting the right teams together. And so the project is pretty much botched from day one. And we all know how difficult these projects are to begin with, and not having the right people, the trust, the right leadership makes it all the more difficult.
Absolutely. No worries. Thanks, Sabine. All right. And we also wanted to know what type of criteria are top of mind when you're selecting an offsite service provider. And really, it's driven by what you would think: cost, schedule, and qualifications. You know, that may not be surprising to many of you. I mean, in a bunch of our different interviews that we conduct with owners in and outside of offsite, this is what we hear about. You know, what's the cost? When can you get it done for me? And what's your resume look like? You know, I mean, I think it's really important to just highlight that these are still at the forefront of what people are looking for in their contractor selection. I mean, we hear these across the industry, and the key with offsite is going to be teaming with the right contractor who's going to get the job done, you know, the right stakeholders who are going to get the job done for you. It really goes back to finding those right partners, as Sabine was talking about, and getting them in the room early. And when you're thinking about cost, you know, it's not always cheaper up front. There's heavier investment, obviously, with offsite up front. But I mean, the savings that you can have in schedule, if you save 1 year on your construction, you can start making money so much earlier, which can really, really help to reduce costs significantly. So we just have to remember that the cheapest bids in this situation among these contractors, I mean, they're not necessarily the ones that are going to be cheapest in the long run. So the last part we have here, besides the strategic implications of offsite construction in the survey right now, a lot of what we saw related to culture and how it has slowed down a little bit of innovation and progress that the industry has been making. What we want to start with are the top perceived benefits of offsite construction. And these were the same year over year in the survey, which really shows how important they are. Reducing time to completion, reducing construction costs, the total installed cost, and improvements in worker safety. You know, these are at the forefront. These are kind of the table stakes of offsite construction. This is what everyone wants to gain or is gaining from the use and the implementation of offsite construction. And I think obviously reducing time and reducing costs, everyone wants to do that no matter what on their capital projects. And then I think improvements in worker safety is worth highlighting as well, because I think it's really important. Safety's come a long way over the last 100 years in our industry. You know, now the benchmark is 0 incidents, and offsite construction is exciting because it's a way to move a lot of the construction process and potentially some of the more dangerous jobs into a manufacturing setting where safety can even be more at the forefront and even better for our industry, you know. So these are the top 3 benefits, but I really think it's great to see that safety's still in there, that it's in everyone's mind still, you know. It hasn't really gone to the back burner. I think that's important here to highlight.
I'd also like to add, you know, in the context of this pandemic, I think the whole safety discussion also is changing.
Mm-hmm.
And offsite construction will hopefully get another boost from that, because it does require less people in some ways, or it's in a just more, you know, cleaner environment, safer environment. So that's a discussion that will certainly, you know, come up more as we're speaking with contractors, engineering firms, and owners, and how that can improve on the job site.
Absolutely. I mean, COVID, I'm sure I'm going to touch on it in a little bit here, but it's changed so much in our industry and construction, you know, and we're still waiting to see how the dust is going to settle and how things are going to look afterwards, whatever, when we return to normal here, whatever that looks like.
Totally same.
All right, and here's some of the top challenges we saw when we asked what criteria are top of mind when selecting your offsite construction service providers. The top challenges, they all pertain to lack of knowledge and planning. You know, the top 3 here that we wanted to highlight: earlier and more robust engineering requirements, a lack of qualified people, a lack of understanding of new processes required. And this is a little different. I mean, well, it's similar because in 2017, the biggest challenges were people related, right? So we had people in 2017 was the focus, with a lack of knowledge and experience, a fear of taking new risks, and a reluctance to change. Those on the right side are the 2017 top 3. And what's different now is that it's really pertaining just to a lack of knowledge and planning around offsite construction. You know, people are looking for the right qualified people. There's a lack of understanding in the new processes required around offsite. And something else we wanted to highlight here was just some of the other uncertainties in the business world in general right now. You know, if you think of geopolitical uncertainty, you know, depending on the U.S. infrastructure push, however that may go. I mean, we could potentially have a problem with skilled workers as they get scooped up and paid more to go work for all these owners who are going to be competing for talent in these projects. The more experienced offsite owners will have an advantage. They will have less reliance on labor in the future and potentially be able to make the shift to infrastructure and to make shifts that allow them to thrive in the new environment. Another, when you're thinking about different geopolitical risks, you know, to offsite or just to the construction industry in general, you know, there's continuation of trade wars in general, you know, the implications for offsite facilities abroad, and what that means for international business, you know, raw materials pricing, that can definitely be impacted depending on how trade wars escalate. The other challenges that are coming up, as we touched on earlier, are really around COVID-19. You know, there's so much uncertainty right now around getting back to work, a potential second outbreak, what the new normal is going to look like. And once the dust settles, how building design will change, and if it's going to change in certain ways, just with the idea of infectious diseases in mind in some of the design and development of these. We did ask about COVID in the survey as well in this area, and what we saw was 60% of respondents, the majority of them cited that COVID caused project slowdowns, and 51% also cited new ways of working as another impact of COVID-19. And I mean, they were impacted not much different from other industries here. You know, everyone saw their projects slow down. Everyone took a pause and said, what's going on here? You know, what are the implications of this? How long is this going to last? And as we can see right now, I mean, the implications or the effects have been long lasting, at least for the rest of this year. We're doing a lot of events like this virtual now. I mean, we're all finding new ways of working, you know, albeit virtually. And the COVID-19 crisis is just something that's going to be kind of in the forefront or on the back of, at least on top of everyone's minds, as we continue to navigate some of these other challenges that have hit us in 2020. All right, and here's the final survey question that we came up with. I'll explain this one a little bit. We asked what top 3 issues would speed up the adoption of offsite construction, and we had respondents rank their top 3. And we had a list of maybe 8 to 10 different items. These are ones that we averaged them together, people's rankings, to decide which ones average ranked closest to number 1, which ones on average ranked closest to 2 and 3. And I mean, if you look at the rank 1 here, we have corporate culture that accepts and embraces the change and is willing to invest time and money to see that change through. And we have well-planned and written business cases approved by senior management. So these are the top issues that were ranked number 1 that would really speed up the adoption of offsite construction. And it's all about culture and people and talent development, really. If you think about senior managers right now in your organization or any other organization, you know, maybe they're not involved in the day-to-day of the offsite construction. They might be at a higher level in the chain of command, really not down in the weeds of these projects, you know, and not really driving progress on them or really showing the C-suite and executives the advantages that some of these offsite construction projects potentially have. They might be concerned, top management, you know, and with certain corporate cultures might only be concerned with keeping shareholders happy and may not be willing to invest heavily in offsite construction as it may be seen by shareholders as too risky. You know, they might be pleased with how the business is operating now and just want to slowly get into offsite construction, but don't really want to take on the perceived risk that they may see in it. And I think what we're going to see now is, what we hope to see is people developing really clear written business cases, as is said in that second one under rank number 1, because that'll help to kind of change senior management's mind and get them thinking more about offsite and really know the benefits that they're going to get out of adopting offsite construction. What we really see success with is kind of an internal champion, someone who serves as the direct thread to the C-suite for offsite construction. I mean, something to the extent of what we'd call them would be some sort of internal champion, you know, someone who's going to serve as the internal champion of offsite construction, be advocating for its use, and be doing things like the feasibility analyses, reporting those findings to management, and then really conveying the value proposition of offsite to the entire organization and make sure progress is being driven forwards. And what that would lead to is more organizations adopting strategic initiatives and setting goals for offsite construction, because that's what we really didn't see earlier in part 3 of the presentation. Was it's increasing, you know, I mean 16% in 2017 of survey respondents had offsite stated goals, and this group, I think it was around 35 or 40% in the poll that we took earlier. So we're moving the needle a little bit there, but in the future, you know, as that gets continued to push more throughout the organization, we think we'll really see hopefully a ramp up, you know, in the speed of adopting offsite construction, because this is what survey respondents are saying is going to be really important for the future of offsite. So I'm going to pause there for a moment, and we have a space slated for questions. I know there might be some coming up in the chat, so we can take a look there.
Okay, we have received some questions via chat. Let me start with those, and then we can open it up to the audience. How's that, Chris and Sabine?
Yeah, that
Yeah, sure.
sounds good.
Trying to get my own chat box up.
Yeah, I'm trying to pull it up. I'm trying to get the whole summary again.
I think I have one here.
Rob Wagner from Procter & Gamble has asked several questions. Rob, I can only see your last question. Can you ask your first one? And your first question, Rob, was on reference slides 10 and 11 of the presentation. Rob?
Well, the questions that I had were at the beginning, you're sharing the data and saying 2020. To me, 2020 is very segmented. If I said January, February of 2020 when you got your data, I think it would be significantly different than July 2020. So I'm not clear when your data, you did mention later on, you did talk to respondents about COVID, but so my question is when you did the data, and have you seen a difference or a delta in the last 4 months, 5 months on that in your respondents, or anyway, that's the first question that I had.
Yeah,
I don't know if you want
so just to answer that, we did the survey, we ran it back in April, I believe, so right in the middle of everything.
Yes.
And we realized that, you know, this is a snapshot. If we did it now or at the end of the year, it might look very different. And it's actually something we might consider doing again, just to see if there are any big discrepancies between what we found in April and later in the year, or even next year. But you're right, because a lot of the projects have been put on hold, there's been delays. We've got the oil and gas collapse situation, trade wars. I mean, it's just everything, and now hurricanes.
It's not a static measuring point, and there's lots of influencing, and it depends on the industries as well. And I wasn't clear as to all of the industries that you surveyed, but if gas and oil is the major ones, then I can see difference in the responses versus I work for manufacturing, obviously, so, and we are considered essential business. Consumers are buying toilet paper, let's be clear. You know, that's all. I just wanted to like get a flavor for where the data was from what the data set. That was the key for me. The second one was in your practice makes perfect slides. I think that you hit upon a significant point that I'm on the committee team for lean practices or lean approaches, and I looked at the questions or the response that you got from your owners, and it ends up that, to me, I think the majority of those challenges and concerns could easily be addressed using lean IPD practices. I don't know if that's what you're concluding or you know, going to share or not later, but to me, even like, for example, contractor selection is one of the key beginning principles in lean IPD. And if you look at that in your slides, it ends up coming very much to the forefront. And I think that if you look at the top 10 that you had, the top 3, if you identify cost savings, you go down below and it says rework, avoidance, and all that. Those are all cost savings ideas that are generated from the first 2 or 3 bullet points at the top of the challenges. That's all. It's just a comment on. I'm not certain if you're seeing lean in your industries that you hold or not, or is that the challenge? Is that the intent of the slides, is to get everybody moving towards maybe a lean approach, which is a collaborative approach?
Yeah, exactly. And as we mentioned earlier, off-site construction is a very different approach. It's more of a manufacturing, a leaner approach. So the lean IPD concept is very suitable for this. Again, maybe these groups could collaborate closer and see and exchange some of that knowledge. I think it would also help. But it's already happening. I think, again, just bringing everyone up front and looking at this whole design, construct, manufacturing approach differently, that in itself, I think, will help streamline things. And obviously, a lot of the lean stuff falls into that.
Excellent. Rob, those are the questions that I saw in chat. I've received no other chat questions at this time. What I like to do is open it up to the audience. If anybody does have a question, can you unmute your mic, state your name and company, and ask your question? I like to turn it over to anybody on as the audience.
Yeah. Hey, Joe, this is Bill Lewis with Sabic, and I did have a few questions. I thought this is interesting. I was involved with Sabine, FMI, and CII back in 2017. But, the point where he said we're seeing more success across the board. We're actually doing better, and our story's better to tell. But I actually was a little bit disappointed. We are making progress with the, early strategic, goal and a stated goal to use more modularization and offsite construction. But I guess something I've seen with, we've had quite a few of the mega projects in recent history that have had a lot of concerns and issues, and they brought modularization in, late, so they were kind of bailing out these failing projects. Do we think that that's getting people to lean more? What's your thoughts on that? Why we're seeing good results, but we're still not getting it as part of people's strategy? Do you think that's with not having the SMEs, or what do you think's driving that?
I mean, I think it's a combination of things, for one comment that keeps coming up is within the owner organizations, there just aren't enough skilled people and don't understand how to do these projects. And that's a problem. We're seeing that on our side, on mega projects, working with contractors, design firms, and owners as well, where they're saying they're having such a hard time finding people who can actually pull off these projects. And one analogy, I think I mentioned this last year in my presentation, is, if you're used to a stick-built kind of project, think of the analogy of driving a taxi, and then all of a sudden you're building a mega project with offsite construction and everything. That's like flying a jumbo jet, and the skills are not the same. The way you come together and communicate aren't the same. The way you coordinate, all the millions of emails that are going back and forth, how you track cash and all those things on these projects is very, very different, and it's very complex. And in your world, many of you are working across different time zones and countries, so it makes it even more complex. And add to that now all these other things like a pandemic and geopolitical tensions, and it's very difficult. That said, though, I think the owners, and this is again, a call to action here, need to communicate around best practices. What does work? What does make it successful? What are the real key ingredients that we can replicate and share across the industry? And I think that's the way to go. And while progress is slow, and like Steve Jobs said, if you can still believe in it and even think you're crazy to make a change, at the end of the day, those are the people who will make change. If we just all give up, then nothing will happen.
Excellent.
I don't know, Chris, do you want to chime in on that?
No, I think you said it pretty well there. I mean, when you're thinking of people bringing in offsite as kind of a fix-it measure, you know, I don't know necessarily if that's going to be quite as effective or good for the perception of offsite versus if it's planned from the beginning and you can build an entire case study that will show its feasibility to management afterwards. You can say, here's what we were doing at the beginning. Here's our upfront investment, you know, but here we're going to save this entire 1 year and a half on this schedule, and I can show you the cost savings. And then the board can agree on this, you know, our entire executive team can get aligned. I think that will give it the right name. You know, those kinds of feasibility analyses, if they're being conducted upfront and it's planned from the beginning, then I think we'll see a lot more adoption, and hopefully that'll make the business case for the board, and we'll have internal champions advocating for offsite as a strategic goal or as part of organizations' strategic plans. Because the problem is, if you bring it in as a bolt-on fix and the project was already in trouble to begin with, you know, that it just might get wrapped up in the negative perception of that in that example you shared, Bill. But that's the only thing I'd add. So,
yeah. I think that's good because, you know, the committee, we get a lot of questions from owners on, you know, how do we get started? So,
yeah.
So, you know, what you're saying is kind of supporting that we don't have that huge knowledge database of people out there that, you know, can jump right in and get these plans and strategies put in place.
To share another perspective that I received, this is Joe Gianfrido from CURT. As companies are coming back online and been online, they're trying to mitigate the visitors and the contractors that are coming directly to the site. And it's not only that, because of all the local laws, regulations, the quarantines, all the things that are in place. And one of the things that modularization does is it allows the work to shift offsite, where they can control the labor that's working on those modules, working on those prefabs, working on those pre-assemblies. And it's controlled in that environment, not only from a safety, but from all the measures that we do across schedule, quality, cost, and productivity. So it really impacts a lot. But owners are realizing we cannot have this influx of outside visitors that are constantly changing and coming onto our job sites. If we're here to run our lines, manufacture, and recoup the financial economics that we need to do. So modularization is picking up, I believe, just because of some of those business strategies of both health, safety, and the productivity that they need to run the lines coming out of COVID as we move forward. So it was an interesting perspective to hear owner companies state we really have to be driving this as an upfront, real early on business choice and a business strategy that we have to do. So great results, great data. It's a data that's going to continue to grow over the next year and forward. And I really want to applaud FMI. Any last questions for FMI before we move on to the next presentation? Last call.
And if that's it, or if you have any more questions about the survey, you'll receive a copy of our email contact information. So if you have any follow-up or anything that you want to know, just feel free to reach out.
Excellent. Let's give a virtual applause to our presenters, Chris and Sabine, and the co-chairs in pulling this all together.
Thank you, guys.
Thanks.
Yeah, thank you. This is great information, great data. We always enjoy it. Gives us a lot to think about from a committee standpoint on, you know, where we need to go and what we need to provide to, you know, this is the voice of the owner, right? Voice of the customer. So thank you.
Our next presentation is from Jeff Holt. Jeff, if you can request sharing your screen and turn off your mic so we can hear you.
All right.
I see you and hear you. Thank you, Jeff. Let us know if you have any questions.
I'm not a Zoom power user here. We're usually on Teams. So
It is similar. I see your presentation. It's up.
oh, okay, great.
Okay, this is Jeff Holt representing the Construction Owners Association of Alberta. And Jeff is with PCL Industrial Constructors, and he's the operations manager from PCL. Jeff, over to you.
All right, thanks, thanks, Joe. Good morning, everyone. I was asked by Larry Staples of the Construction Owners Association of Alberta to present the module assembly best practice, which was written by a committee made up of owners and fabricators and was published back in 2017 by the COAA. PCL is a part of the COAA's module subcommittee. So the vision of the committee was to make optimum use of the already strong Alberta fabrication capabilities to deliver globally competitive modules. Our goal was to establish, or is to establish and implement an industry accepted modular best practice to improve total installed cost, scheduling, quality, transportation, and safety. The module framework document was developed with the intent that it provides guidance for proper planning and execution. It was developed as a guideline to assist all modular stakeholders in developing their own project-specific module assembly and execution plans. It was meant to be adaptable and non-prescriptive, as well as to be scalable to fit the needs of various project sizes. There are many different commercial models that are used to deliver module projects, so the framework had to allow for contracting flexibility and recognize that organizations within the contracting supply chain have their own specific strengths, weaknesses, and risk profiles. And ownership needs to start at the front end with the decision maker. Early involvement in planning is extremely important. Joe just talked about that. Establishing a modular management team at the front end of the project is considered essential to define the parameters of the modular execution plan for the project. This team could be, you know, one person depending on the size of and complexity of the specific project. The team should be comprised of individuals with, or that individual has to have subject matter expertise in all the elements of the best practice. It's suggested. As a minimum, the team leader should progress with the project to support modularization through both the design and construction phases of the project. So the assembly framework, or the modular assembly framework, was developed as a guideline to assist all module stakeholders in developing their own project-specific module execution plan. So rather than create a document that attempts to address everything through a module project's life cycle, the best practice tool was based on principles as a means of conveying best practices for each modular assembly element. We started by looking at best practices, but it became too cumbersome and too detailed and hard to scale. So the difference between a principle and best practice is that a principle is a comprehensive fundamental truth versus a best practice, which is more a professional procedure. That's sort of the point we got to. And by using principles, it was easier to make the document scalable for different projects. The principle is that all required materials, for example, the principle is that all required materials be delivered to the fabricator at the start of fabrication. And, you know, conversely, a best practice would in turn be created by a specific project group to address the specific nature of the project. For example, materials arriving from local suppliers are required to arrive a minimum of 7 days prior to the start of fabrication, for example. So that would be prescriptive to the project. So we didn't want to get into that sort of detail, but we wanted to establish principles in the best practice. So the tool was based on previous lessons learned in the module industry in Alberta, and gathered from COA owners and fabricators. There are 10 elements of the module assembly framework: design, procurement, contracting, work packaging, fabrication, module assembly, lifting and shipping preparation, transport and receiving, module installation considerations, and completion. And many of those elements are interdependent. And so when you do read the document, if you choose to read it, the reader should use it in its entirety, as you need to be cognizant of all the elements because they may impact one another. So, framework for design. As everyone knows, design is a key component to the success of a project, but specifically a module project, it's important to start early in planning, including the development of a module execution plan and design philosophy, and consideration of modularization during plot plan development is extremely important. Without early planning, projects run the risk of developing designs that do not maximize the benefits of modularization. Therefore, it's key that certain activities are completed before the detailed engineering phase of the project. Also, a key to success is the involvement of the right parties in planning a modularization program. There are key considerations to be evaluated by projects in deciding what to modularize. It's important that you know, if you have a doctrine of modularizing, it's important to also recognize that not everything should be modularized. Some things just don't make sense due to transport. Also, design constraints need to be defined and clearly communicated to the design team to ensure the effective implementation of the program. That's why we suggest that an actual plan, an execution plan is written up. It should also be recognized that all the elements in the module assembly framework include guidance that influences design. So they need to be well understood by all the stakeholders. The framework for design, constructability involvement starting early in the feed stage is important. Things like module installation methodology needs to be clearly established. You know, for example, things like how are you going to set the modules? Are they going to be set by SVMT or Crane, or are you going to include super modules or smaller modules? That all needs to be lined out. Installation sequence or path of construction needs to be established. Prepare the module design philosophy early in feed. So complete the module design philosophy prior to detailed engineering. Needs to be done prior in order to eliminate issues throughout the project. Create engineering guidelines in consideration of this that consider the entire module assembly framework. Early understanding of shipping envelope, for example, well-defined MIWPs or EWP relationship early in the feed, integrated design specifications and standards, alignment considering all different interfaces, for example, transportation and installation codes and standards. Decide what components are included in the module. For example, are pumps going to be attempted in modules, or are they going to be concrete foundations on site. Define the orientation of the modules, establish the datum and ensure it's on each module, consider bolted connections for both pipe and steel, consider design, construction and transportation support of steel. So lots of things to consider. So modularization should be a primary driver as well for the development of the plot plan early in FEED. Develop a module key index or key plan and listing of modules. That can be done at the FEED stage, should be done at the FEED stage. Complete a module execution plan during the FEED stage. That should be done before detailed design as a way of communicating to the detailed design team the modularization plan. So as far as next element, procurement. Procurement, the intent of incorporating a procurement plan is to ensure that with upfront early planning, last minute changes can be avoided. And also with procurement, potential savings can be achieved through effective procurement planning by identifying lines of responsibility for the supply chain. Proactive measures can be taken to ensure contingency planning in procurement, which is one of the bigger elements. We always say there's 3 legs on the table when you're building a module, and it's labor, engineering, and materials, and you're not doing much without materials. So the framework for procurement plan. The plan should include modular specifications. Why that's in here is, I mean, obviously every project has specifications, but it's important that they be fit for purpose module specifications that address modular construction. And oftentimes we see engineers, owners try to bend specifications for into modular work, and then you get lots of RFIs trying to interpret the design. So it's important that the specifications are scrubbed and issued specifically for modular projects. Complete bill of materials, obviously. Destination is important. When you have modularization, now you have different locations for that material to go, and that has to be lined up really early in the process. You have the pipe fabrication shop, the modular yard, and the site. So in procurement, those all have to be broken out, and lots of times projects will want to send everything to a modular yard for marshaling, but it's really becomes expensive to rehandle all of that materials back to the site or out to the site. Save a bunch of money there. Also on bill of materials, approved manufacturers list, client supplier of choice, commodity codes, that all needs to get lined out there. Material supply responsibility matrix, that's important, depends a bit on contracting structure. Long lead items, early identification is critical. You can save yourself a bunch of money there with mill runs and whatnot, but that's extremely important. Availability of materials obviously affects scheduling. Management of material substitutions. Need a plan. You need a separate plan for that. Ensure that construction drawings accurately reflect the materials being substituted. Warehousing and material management plan should include the laydown space requirements, sequencing and priority of material storage and preservation, warehousing requirements, staging requirements, receiving plan, OS&D plan. It's obvious, it's required. Logistics strategy, consider how you're going to handle that as far as receiving capacity in the yards, receiving capacity in the shops, whether you're going to vendor manage some of the inventory so that the fabricator or module assembly yard is going to draw from vendors. A lot goes back to the contracting strategy, but definitely a plan is needed, and it's needed early. Framework for contracting, early planning and development of the project contract strategy and processes. Once that's defined, that'll give the project team strong guidance on issuing contracts and the minimization of risk. Will minimize risk for the project if those are effective contracts. So define sufficient time for the contracting cycle. Lots of this isn't modular, specific to module contracts, but we included a section on it because it's so important to have this done early. Yeah, define sufficient time for contract cycle, bid qualification assessment, selection, negotiation, and award. More detailed planning and engineering on the front end there will improve the bid cycle time and the accuracy. Develop a contracting strategy, including your pre-qualification, type of contract, early transmittal of terms and conditions. As a contractor, I can tell you it's so frustrating to try and make up schedule that is lost by contract negotiations. Very frustrating. Provide a well-defined scope of work, and that will help a lot. Complete set of ISC drawings, if that's the strategy, minimizes recycle and change. Schedule and module sequence. Nailing down the module sequence is extremely important. Specifications and guidelines as well for the scope of work. And also prepare a closeout plan, including notice of completion, statutory declaration, lien waivers, claim resolution plan, warranty. All those things need to get lined out for sure. So that's why that's been included in the framework. Now, framework for work packaging. The purpose of this section is to provide the module management team with recommendations to consider in the development of complete and consistent work packages. The expected results of a good work packaging program are increased productivity and control, which ultimately translates into lower costs. And Michael Stone went into detail on this in his presentation yesterday. Let's see here. As far as the framework for work packaging, some of the work packaging elements. Some of the work packaging elements need to be defined with all the stakeholders, and they need to be agreed to. So I would suggest a kickoff meeting very early in feed, and it's important for the engineering and owners to include contractors as a stakeholder in those packages, because ultimately it's those contractors that'll be using those packages and interpreting those packages. So it's important that the information is pertinent for everyone. Otherwise, the engineer is just spending a lot of money and time making packages that maybe don't apply or aren't necessary for the fabricator. And there might be some things that the fabricator needs that aren't in the packages. So scope of work, it's important to get that, like I say, well defined. Model shots, summary descriptions of the scope of work, work excluded, work included by discipline, key execution milestones. It's important to have in there as part of the elements of the work package. Technical documents, list of all EWP associated packages for structural steel, piping, instrumentation. Applicable specs, I talked a little bit about that. Drawing lists by discipline, module key plans, P&IDs, isometrics, system scoping drawings, module GAs, the whole works, instrumentation lists. Important that everybody decides on those and how they're to be issued by the engineer. Materials, material responsibility matrix. Talked a bit about that in the procurement plan, but that's extremely important. Provide BOM by module that covers all the disciplines. So lots of times we see the BOMs not by module, and that's not super useful. If you're trying to construct modules, they need to be broken down by module. HSE identifies safety considerations and precautions, often overlooked in work packaging, but things like use of nitrogen purges and things like this, and that may need to be implemented on the modules. Quality, code of construction, inspection and test plans, special preservation requirements, regulatory permit requirements. It's good to start talking about all those early on and get those lined out early on. Specialty subcontractors, high voltage testing and inspection, things like that, whether that's required. It's good to know those things early. Vendor support, whether there's some equipment on the modules that requires vendor support. It's important to get that lined out early, because the vendor may be required to have a presence in the module yard and then also a presence at site. And sometimes those requirements aren't reflected in vendor support contracts. Project controls, to integrate with the schedule, progress and performance measurement. It's important that the work packages support the breakdown in order to progress properly the work. Risk register, good idea to run a risk register for modularization. Work phase planning. Including a detailed list of associated work packages. Turnover, system definition, tag cross-reference lists, pre-commissioning. We'll talk about a little bit, but what scopes can be done in the module yard before things can be sent out. Oftentimes we're completely wiring modules back to junction boxes and doing loop checks and everything in the module yard instead of at site. And so a plan around that needs to be made. So yeah, a note on work packaging. We often receive elaborate work packages from owners and engineers, and end up only using portions of them. And so, and conversely, sometimes we need more details. For example, often things are broken out to the module level, but we always break them out further to the individual levels of the module. So that's how we typically construct modules, is that the lower level of pipe will go in, and then we'll continue with steel erection, and then the mid levels and then upper level of pipe or cable tray will go on. And so we further break down our modules in order to control our work further than the module level. And so that's something that we're doing on our own, and typically, and so I think it's worthwhile, depending on the contracting structure, for engineers and owners to bring the contractors in early to understand how they work, in order for them to be successful as well. So framework for fabrication. So the purpose of this section is to ensure delivery of fabricated materials in an organized manner to support effective modular assembly and ensure completeness of prefabricated packages. The expected result of properly planned fabrication is an increase in workable backlog. As a modular assembler, workable backlog is very, very important for us. What I mean by workable backlog is when we understand, I'll give you an example. We understand workable backlog very well in the fabrication shop. How many diameter inches are ready to be released to the floor and welded up at any time. That helps us control the schedule. It helps us control our manpower. When we know that we have work that's readily available. And so we transfer that concept into the modular yards, and we try to control our workable backlog. We don't want to send anybody to the lower level of a module when all the components aren't available to be installed in the lower level of the module. So all of the piping spools, all of the supports, spring hangers, what have you, we need to be work packaging effectively, and then also translating that into progressing not only the physical work that's done, but progressing the workable backlog. What's available to be worked on any given day is very important to understand, and it's the key to better productivity. We don't want our guys going around looking for work to be done. For example, installing 10 out of the 17 spools that are on the first level of a module. It's just a waste of time to go back to that module when those other 7 spools are available, or when they can be found. So we want to ensure that we're controlling workable backlog. Something I think Joe talked a little bit about, controlling the work better in smaller chunks, and really increasing productivity over what we would see in our field installation productivities. So important to control the fabrication and know where it is and when it's available to be installed. How to do that? Engage the fabricator at the earliest stage of engineering design. Understand the scope of services that the fabricator can provide, including welding capacity, shop capacity, space capacity. Identify the extent of pre-assembly that can be done. Update the module, and then update the module execution plan as required, depending on what fabricators the project is going to use. Issue finalized IFC drawings prior to commencement of fabrication work. Sounds easy, seems hard to do, but it's important. Deliver all required material to fabricator prior to the start of fabrication. I mean, if the fabricator is purchasing, I mean, that's their responsibility, but a good thing to keep an eye on. If you don't have any material, you're not doing much. Deliver all, where am I here? Avoid design of module fabrication level by including all required fabrication details. And this is one thing that, you know, we go back and forth with engineers and owners on a little bit. It's for us in manufacturing, we look at fabrication and module assembly as more as manufacturing. And, you know, lots of times I think a legacy of field engineering is field run. So lots of times we'll be asked to field run 2-inch and lower, or we'll be asked to field run tray. And when you're trying to run things in a lean manufacturing sense, field running is just not what we like to do. So if the owner and engineer is adamant that that's not available, we'll make our own drawings for the field run and cable tray, and we'll put them into our own work packaging and work orders, and we won't have our people you know, looking around a module to try and figure out where pipe will go. We always give those instructions and have the material ready. We do that with our coordination staff rather than our tradespeople. And maximize prefabricated assemblies for construction efficiencies. This is an important point. For modular assembly, hydro testing is typically required in order to put on the insulation, obviously. And so lots of times we'll pre-assemble the valves and everything depending on the owner and engineer's hydro testing philosophy and what we're allowed to test through, but we like to put all of that together and put it through a test and then put it on the module. And due to the winters here in Alberta, we can do a lot of that work inside, and then it becomes just a loading or a rigging operation where we're rigging pre-assembled spools which have all of their inline components bolted together before it goes into the module. And so we create sub-assembly drawings which show the fabricators what to assemble as far as bolted connection, bolted valves, bolted inline items. They all get bolted in and then hydro tested, and then it's a rigging exercise in 30 below weather for us, rather than trying to bolt up valves and do hydro tests with glycol, etc. in those conditions. So a little bit of a driver for us is the weather here. So framework for module assembly. The module assembly strategy should identify and incorporate an assembly plan that supports the installation sequence priority. I can't sort of impress on everybody enough the importance of the sequence of modular fabrication, especially if you have 100 or 200 modules. It's pretty hard to change the sequence, and so a lot of time should be spent on understanding that sequence. So some of the principles and practices include issued for construction design models. They need to be available for the contractor, modular contractor. We as a contractor have become very adept at using models, and in order to describe the work to our tradespeople. And again, this gets back to work packaging. Where's the biggest bang for the buck to try to get the lowest installed cost? And we're typically operating lump sum, and so we're doing that ourselves if it's not provided by the engineer or owner. And so there is money to be saved there if we're involved early, that can reduce some of the costs. But design is complete before assembly commences. Module assembly contractor is engaged as a stakeholder in the engineering, procurement, and construction schedule. It's an integrated project schedule. Lots of times we're asked how much time it takes to do the modules, but if you can get integrated in when the engineering arrives and when the procurement or the material arrives, then these schedules can be shortened. Modular contractor utilizes work-based planning and lean manufacturer principles. So when in your selection of your contractor, I would highly suggest you look at whether they're utilizing work-based planning and lean manufacturing principles. We utilize in our yards last planner. QA/QC requirements are defined upfront by stakeholders. Materials are shipped on time, limit requirements for marshaling and handling, and ensure whoever you choose, their modular yard infrastructure supports your project goals. Framework for lifting and shipping preparation. We've got this in here. It's extremely important that this is understood up front, as far as right in the feed stage of the project. You have to understand your transportation route. You have to understand the capacities or the weights of your modules. Oftentimes, unfortunately, we wind up taking items off modules because they're overweight. And I know it's not an easy thing for engineers to fully develop the weight of a module in the design stage, but oftentimes when we go to weigh the modules before we transport them, they're unfortunately overweight. So this causes lots of problems. So good area to focus on. So some key things: minimize the number of lift points and standardize base spacing. Your on-site contractor will thank you for that, and you'll have a lower installed cost. Modules with unequal lift lug elevations. Again, this is going to cause a bunch of problems with your rigging plans on site. Lifting lugs to fit the required shackle size. When you're studying the lifting lugs, it's something that's described early, and if your lifting lug holes are too small or the lifting lug can't take the weight, then you've got a real problem. So it needs to be considered very early in detailed design. And then some, fundamental design considerations that are extremely important. Things like center of gravity, eliminating obstruction of lifting lugs, eliminating hanging equipment underneath. Quite often we see spools that are snorkeled underneath modules, and that causes lots of issues with transportation. Ensure weight, again, control the weight through design. Ensure width and height are controlled. I'm not sure how it is in other parts of the world, but they're pretty strict on the shipping envelope. In lots of the jurisdictions that we ship through, it causes big headaches with the permits. Shipping season, when developing this construction schedule, where we are up here, you can pretty much ship anything in the winter because everything's frozen. But at other times of the year in the spring, things get kind of soft. And so very important considerations, because now you've got some pretty definite constraints on your schedule. And so that's very important. And then also ensuring adequate tie down provisions and lashing. You want to get provisions approved by the engineer or designed by the engineer that don't cause you to have insulation blockouts, for example, because you're going to have to go back and fix those up when you get to the field. So designs like the one in this picture here, where you're using all thread and just you're anchoring the supports without affecting the insulation. Things like that need to be considered and are important time savers, money savers. Transportation and receiving, lots of considerations again here, and it's amazing how early on in your project they need to be considered. Transport beams, integrated shipping beam on the lower level of the module is a big, in our part of the world here, is a big saver. Otherwise we have to use what's called shipping beams, or additional beams go on the bottom of the module and span to the columns. And if the lower transverse beams can't support the load of the module, which unfortunately engineers sometimes figure out too late, and then we have to use shipping beams. But then you have to purchase, rent, or rent shipping beams, and it just adds to the cost. So if at all possible, the lower portion of the module should support the weight. Self-loading versus hoisting the modules. We don't really want to get in a situation in the yards where we're hoisting modules and bringing in heavy lift cranes. The whole purpose of the yard is to do work at grade, lower down, where you have better productivities, less scaffolding, and then also we don't have heavy lift crane expenses in the yard for lifting these onto transports. So the module should be designed to be transported on self-loading trailers. And, you can save a lot of money doing that. Also, there's a certain rigidity that's required to transport modules, and so the engineer needs to consider that. And lots of times they'll design temporary steel to be incorporated in the module for transport. But the best design is if that steel can be left in, because you don't want to spend man hours at site taking steel out at higher elevations that's obstructing walkways or what have you. It's better just to make it incorporated into the design, and then you don't have to spend man hours at site. Receiving, straight to hook, just in time. It's often the basis of proposals. We find more often than not it's difficult to achieve for weather, for transportation constraints, and the like, especially if you have a 100 or 200 module program. It's good to have a backlog of modules on site that can be set at any given time by the crews at site. We don't want people waiting around at site for modules to arrive. But modules do take up a lot of room, so you need an extended laydown area. So those are things to consider. What's your on-site laydown area for those modules? Straight to piles is often a strategy we use where the self-loading and offloading trailer. Your piles are designed in such a way that the trailer can go between them, and then you just drop it down straight on the piles. Obviously, that's only works for the first tier of modules or things like e-houses and the like. Yeah, module installation. PCL has spent a long time optimizing, a lot of effort optimizing module installation. For our work up here, and you probably noticed from a lot of the pictures, they're not enormous modules like some of the modules we see in Houston that are built on the coast and barged to the sites. Our modules are primarily confined to 24 feet by 24 feet, 24 feet wide, 24 feet high, by 120 feet long to 140 feet long. And so the challenge is to lift those modules without an enormous crane and boom. And we've developed these lifting frames that you can see in this photo, a couple of them here. And that allows us to get that boom tip height down, and then also allows us to quickly change bay spacings and account for center of gravity on module lifts. And so where we were getting one module a day by setting up a Christmas tree type rigging arrangement, we're getting 2 or 3 lifts a day, or 2 or 3 modules per crane in a day when we can utilize these lifting frames. So that's a shameless plug for PCL there. But so module installation best practices: reduce work at heights, early involvement by modular installer. The path of construction is extremely important. Crane selection is extremely important. Heavy lift program overall. The course of it needs to be established early. That's an additional execution plan, additional to the module plan. Bolted construction of interconnects sometimes it's considered. It's difficult with lots of the line classes that some of our clients have. Pre-assembly at site. Some modules can be further assembled at site. If they have ladders and platforms that were over height, they can be put on before the module is hoisted. And construction supports, and also plan for conditions. Some of the things to be aware of. And then finally, completion. Completion best practices: define pre-commissioning and commissioning requirements. I mean, this is always always seems to be a bouncing ball going back and forth all the time. What are the requirements? What do the owners want to do or do in the module yard versus do on site? My suggestion is a clearly defined DOR on pre-commissioning, and then one on commissioning as well, and just get that all lined out before we start module fabrication. And define turnover requirements. Things like redlining, all of those things need to be defined early. Define all temporary materials that must be removed at site and how you're going to identify those in the module. typically we're either painting those a different color or providing an as-built, which is identifying what needs to be removed. Because oftentimes owners want their pipe shoes welded down, and that causes problems for stress. And so we want to make sure that those are taken off properly in the field when it's field erected. Remediation and deficiencies and scope transfer. Yeah, unfortunately, sometimes schedule causes decisions to be made where modules are incomplete, and it's really important to define what hasn't been completed when it hits the field, so that they have a good list of deficiencies of if those occur.
Hi, Jeff.
Yeah.
This is Joe Gianfrido. I have received several questions.
Oh,
if I can
okay.
ask you to go ahead and hit your summary real quick, and then a lot of them are going to address a lot of what you have on this next slide. So however you like to handle. If you want to hit this quick, and then I can ask.
Okay, I'll do that. Sorry, Joe, you were breaking up. I hope I haven't been breaking up during my presentation, but I'll go through this final slide here. I guess in general, all these elements that the subcommittee put together seem rather simple, but I'm always amazed to see owners and engineers get tripped up on the details of one or more of the elements. And usually if they're not considered early, as I've been suggesting during FEED, these challenges start to present themselves, and stakeholders start to make compromises, and some of the value that was intended to be recognized through modularization can become diminished. So you really have to be rigid up front in planning when it comes to modular. A lot of times, it's all too easy to talk yourself into, well, I'll do that in the field, or I'll pick that up later. And that was part of the goal was, to improve total installed cost, and that just doesn't get better when you pick things up later. And so sometimes, we see some of these decisions being made, and it really takes discipline to modularize effectively, because your engineering needs to be available all that much sooner in the project schedule. You basically complete your engineering when you're done the modules. There's not much left at site that really needs to be done, but as far as engineering is concerned. So in summary, again, the goal was to establish and implement industry accepted modular best practice to improve total installed cost, scheduling, quality, transportation, and safety. I think the group has accomplished that. It's important to note that the tool does not, you probably noticed I didn't address safety specifically, or we didn't address safety specifically as a group in modularization, and that's already, established in the best practices of ourselves at PCL, and then also in the COA, other COA members that were involved. So we chose not to include that in here, but it's very, very important. And if you can control your work properly, you have a much better chance of controlling safety on your sites properly as well.
Okay.
Again, the document is a guideline that can be used in developing a module assembly strategy and execution plan specific to the project. It's available on the COAA modular assembly, under module assembly on their website. You can see down here coaa.ab.ca, and there's also lots of other interesting best practices on there for other topics that have been introduced over the years by the COAA. It's a great resource. That's all I've got.
Hey, Jeff, I got just a couple of quick questions. I believe you've addressed them, but I need to ask them. It's
Sure.
via chat. How early do you recommend the construction resources to become engaged in the design execution plan? It's from Bill Lewis of SABIC. I believe you addressed that, but Bill, do you want any further elaboration?
No, on the questions that I asked, I think he's already addressed those through so I think we're good there.
I thought as well. So let me go to the next question. It's from Procter & Gamble Company, Rob Wagner. How do you plan the integration of different owner equipment modules, delivered modules, and the points of contacts need to be planned? I believe you addressed a lot of that already, but I wanted to turn that over to Rob. Rob, do you want further explanation of that?
I can comment on that.
Okay, go ahead.
Well, yeah, it's a great question. Vendor packages often represent one of the greatest challenges for us in not only our site work, but in also modularization, depending if for example, a lube oil skid provided by a vendor, for example, this is, you know, often challenging because the package itself needs to get integrated into the module, and oftentimes we don't have a lot of information that's provided by the engineer.
Right. Yeah.
And it can present definitely some hiccups. And
Yeah, my comments, you had mentioned about the fact that often the modules can be pre-tested in the shop, and therefore the integration and all that. So you need to get everything together and coordinated. You answered it. It's complex. that's and it needs to be watched.
Yeah.
One last question real quick, and I believe it's an important one. In your experience or what you've been exposed to, do many of the module yards have good advanced work package processes in place?
I would say no. From what I've seen, it's been an ongoing development for us. It's taken a lot of effort. We're now on an electronic ERP system, which enables us to understand what we have on hand, and like I say, control our workable backlog. But these systems are not easy to maintain, and they're not. I don't see them at a lot of the smaller yards. It's something that what we have is the drawings create a demand, and we have a certain inventory, and we want to match the inventory with the demand on a certain work package. And also too, we want to make sure that the most relevant work package is being worked on. We don't want a work package that's 20 or 30 modules down the list. We don't want to assign material to it when the most important module doesn't have all of the materials assigned to it. And so our system dynamically allocates materials to the most important priority.
One last item, and
there's no hard allocation. And so yeah, I would say no. I haven't seen a lot of that across the industry here in Alberta, but I think it is important.
okay, thank you. One is a learning share, and then I'll open it, and then I'll share how we're going to recover schedule. Rob Wagner, Procter & Gamble shared, engineering model is billable hours, so large packages become the normal deliverable. Can address this waste by early involvement for all, installers and design together, collaborative design and install. And what he shared was tech planning can assist in his waste of assembly and the control of the better as Jeff noted. So he's reinforcing that what Jeff has shared is some of the experience that Procter & Gamble company and Rob has experienced, and in his work thing as an information share. Hello, everybody, and welcome back. Thank you for your questions that are coming in. Thank you for all the names that I see here. It looks like we have people rejoining now. So as Andy gets ready to pull up his presentation, I'd like to introduce Andy Pan, and I believe I owe you an apology. Your company name is Wiesen, correct?
Right.
It's Wiesen
Correct.
Engineering, and I pronounced it incorrectly earlier. So I had to go to international versus U.S. verbalization of the company. So it's Wiesen Engineering. And Andy, thank you for joining us. Can we help you request
Yes.
share screen and PowerPoint?
Right. I just put on the share now. I couldn't find my slides. Yeah, I saw my slides. What should I do now? Just say
Click
share.
share and then click your slides, and it should pull up in a minute. Here it
Okay, I
comes.
got it. Yeah.
Yeah.
Here's the,
Yeah, there it is.
We can see it. It looks great.
okay, great.
And
So-
Andy, when you're ready, go ahead and introduce yourself, and we'll move forward
Thank you.
with the afternoon agenda. Welcome back, everybody. And again, this is being recorded. So if you come in late, or if you have to step out for a call, or your business is, you have direct access back to what has been shared and taped. Thank you, everybody. And go ahead, Andy, you're on.
Yeah, good afternoon. My name's Andy Pan from Wiesen Engineering. And the on the screen shows Huawei. That's not a popular name these days. It's not my name. It's just the computer I'm using. Okay, let me start. All right, start the first slide to the subject of my discussion today is the cost comparison of modules versus stick build. All right, now this first slide.
Andy, you may, there you go. Thank you.
Okay. The first slide, which shows a ocean liner carrying the modules and delivered to the port near one of our job site in South Texas. I just like this picture, then it looks good. Next one is the sections we're discussing today. First one is what is modularization, and second one is why modularization, and third one is modularization roadmap, how it was developed, and the last one is the comparison of the cost to the stick build. Why modularization? You know, I think the definition of a modularization is a strategy for the construction stage, and it was originally developed for the offshore oil drilling platforms. And also modular is complete assembly of the equipment, bulk material, and components, and which will be fabricated off-site into a structure and to be transported and stored in another location, which is shifting the fabrication efforts, the construction efforts from the job site to another location. Next slide. Why modularization? I listed 9 advantages, as in we all know, but just want to repeat the discussion again. First one, reduction of the capex. We know all the purpose of this is reducing the cost. And by shifting the construction locations from the job site to a lower cost and more productive area. And we have can have a shorter schedule, which means we can do for example, project, the construction of civil work. At the same time, you're doing the superstructure at the same time. So that's one way to save shorten the schedule and lower the construction risk. Of course, you're doing the work. Most of the working will be in the fabrication yard. Have a safer location, safer environment. Can lower the construction risk. Site and logistical risk, of course, can be reduced, and weather and climate issues. especially for the job site, you have severe weather conditions. Like in Siberia, they have the weather temperature lower than 40 degrees. Most of the winter season, you're not going to work in outdoors. Therefore, you have to using the advantage of the module to fabricate other areas and deliver it to the job site. And also in areas like the monsoon seasons, 4 or 5 months a year, then also the advantage is to build the module outside the job site and bring it over. And another reason is the labor and skill shortage. That's also common in certain areas, especially in very remote locations. You do not have enough labor and skill and even the equipment to bring over to the job site. That's another advantage for the module. Of course, the safety and security concerns to build the construction of the module and the different job site, outside job site in the fabrication yard, you have better controlled environment. Again, the same reason for improve the quality control, and also the same reason for reducing the environmental impact. There's a modularization roadmap. As modularization has been evolved from stick build to site pre-assembled build minor workshop near the off the plot, and to the local module build and the road transportation from the local yard, and to overseas module build and sea transporting to the job site, which means that another thing is shifting from the low cost, high cost labor cost area to a low labor rate cost area to do the fabrication. And the last one is the last stage is, as we are doing now, is the mass module build and shipyard mass production. So again, the trend has been from the minor offset assembly to mass module build. And of course, modularization, which must have always provided benefit at acceptable cost and the risk. And as in Flora has determined as a term, the generation stage of modularization into 3 generations, as I know of today. So the modular roadmap, how we define the generation. The first generation is just the pipe rack and the pre-assembled racks. Just small pipe rack for the just small pipe racks. That's we consider it as the first generation. The second generation is the first generation plus we put equipment of pre-assembled units, and plus and add on the pre-stressed vessel, for example. And in this generation, 40% of the equivalent stick build hours can be relocated to the fabrication yard. The third generation, and we can this is really to maximize collaboration with owner, engineering, procurement, construction, management, and fabricator to come out a maximum standard design to allocate 60 to 90% of the equivalent stick build hours to the fabrication yard. And this will, of course, substantially saving the CapEx. So what are the modules, we're chosen can be chosen as modules? First one is the process unit. Another one is of course, staircases, some small industrial buildings, and pipe rack. This may be the 4 major system can be built to module. This slide I named Thinking of Modularization, which really means that we need to plan early for the modularization. And just like Jeff has mentioned that too, you want to have, even the feed stage, you should start engage in the planning of the module. So I listed in the 3 different stages. The first one, even in the pre-feed stage, we should start the feasibility study and engage with the logistic company doing the traffic survey. So at least we know physically we can transport a sizable module to a job site and to make, economical viable. And this is in the pre-feed stage. To be specific, I think that's what we need to find out, at least to determine a preliminary envelope, dimensional envelope, and the weight. Sooner we decided this is the way to go. So during the feed stage, we also has to engage with different stakeholders. I would say procurement, construction, and logistics supply vendors, and to come out a best operating scheme and for the feed design. Another important thing for the feed stage you have the modularization considered is we can reschedule, regroup the plot plan different than a different than stick-built plot plan selection. For example, if we have three phases or two or more than two phases of the projects, so the first phase of project, if we better to move locate the project further away from heavy haul road or further away from the ocean coast, because for the easy transportation for the next two phases of the project. That's one example. Another one is that we need to, for the feed, we can do the piping routing study, equipment layout to move one system into a common module to simplify the installation and to simplify the commissioning effort. And last one, we have to consider in the detailed design, of course, we have to consider all the different design and load conditions for the module. Even because for the module, it is different than the stick build will be the lifting, lifting criteria, moving, ocean transportation, different loading catering, ocean transportation. Those wave actions we have to consider in the detailed design of the structure. That's I mean by thinking of modularization, to plan the work during the pre-feed, feed, and design. Now we're talking about a cost comparison. This is a bar chart, sources from IHS, and for the fourth quarter of 2015. And this chart shows the distribution of components, cost components for the project around each global areas, regions. And let's take a look the North America, the labor cost. In the North America, the labor cost is 40% of the total project cost. And compare with the, say, Middle East is about 20%, and compared to Asia is about 18%. So that's the advantage right here. Now you can see if we move the labor cost, man hours, from North America to the lower cost regions, that's the one way to save the cost. That's one advantage of the module. The other one is that because of moving the cost from the job site to a job for fabrication yard, you have improved the productivity. That's another reason we can save the cost. That's why the module becomes an important factor now, the trending for almost all the mega project construction in North America. So that's really the primary reason we consider the module as the strategy for the construction work in North America now. We made a cost comparison now I listed 3 separate projects, and for this as a case study to show the differences. The first case is the small pipe rack. I say the very small pipe rack because that's the first project we did in North America, and with modularization concept. And it's also the first project we're really testing the water of using the module concept to do a project in North America. The second case is not a real case though. The second case is a study case requested by a client who is going to build a project in Gulf Coast, who is a 200 KTA and PP plant. And the purpose of the study is one has to justify how much saving they can have by doing the module instead of stick building this plant. The third one is the case is a project we are doing right now, closing out. Closing out this project is a 820 KTA ethylene glycol plant. And we also fabricate a module in Asia, and this construction site is South Texas. Okay, let's start the cost comparison of case 1, the small pipe rack. And the first item I list as material, the reason is give you a perspective of the size of the project. It's really a smaller one. The piping only 3,000 short ton, and structural steel, so 970 tons, and the cable tray length about 9,200 feet. You can see compared to stick build quantity and the module quantity, not much difference, only the structural steel. And that's obvious because the structural steel, because transportation and lifting requirements, we have adding extra loading cases to the module, so the structural steel will be increased. In this case, not much, only about 5%. Normally it's about 5 to 15%, and it depends. But for the smaller job like this one, 5% we find reasonable. And that's what the end results. Now we're talking about man-hour savings. We consider stick build as 100% man-hour use because man-hour used. For the module, end of the construction, is only 80%. The man-hours is about 80% of the stick builds. And you can see if it is divided into different categories. For the engineering stage, for the engineering man-hours, not much differences between the module and the stick build. And for the fabrication, of course, module will have much higher percentage of fabrication. In this case, about 51%. And the stick build, smaller pre-assembled structural and piping will cost about 22% of the man-hours. And the construction, though, make difference too. The stick build will cost about 63.2% of total man-hours, but the module only costs about 14.3%. So end up, the total saving of the man-hours, shifting man-hours, is about 20%, 80%. 20% saving. Next one went to the cost. Man-hours cost is by 80%, modules by 80% of the stick builds. But for the real cost, it's about 73% of the stick build. I think the 73%, why is the 73% about 27% saving? And if you look at the different activities for the engineering and project management, again, the cost difference is not that much, and the procurement is not that much. Only module maybe need more effort, because more cost because of the steel structure. We'll be adding more, and the fabrication cost. The module is about 13.2%. For the stick build, is only 5.7%. I mean, cost-wise, and transportation module will be about 23.1%, and stick build only about 5%. And at construction, the total cost for the stick build, it's about 72% in this case. And for the module construction, only about 20%. So total cost saving in this case is 27%. Again, with the important factor of this analysis, one of the factor is that not just the cost difference of the man-hour rate difference between North America and Asia, again, because of productivity. Based on our current over the 2 or 3 project experiences, comparing the United States craft labor productivity, and in Asia, we found structural steel-wise about the same. But the piping, construction, erection, the Asia fabrication yard is about twice as high productivity than the job site, field productivity in North America.
Andy,
Yeah.
if I can interrupt, this is Joe Gianfrido. I did
Sure.
receive several questions reference what you've just shared, and I think it's going to be easier to answer now
All right.
versus later. So if I
Sure.
may, can I ask a couple of questions that we received?
Go ahead.
Okay, one is in the cost comparison, are the totals all the same on the graph? Example, steel costs more in Asia. This was back on slide 12. It was 2 slides before this, but do you recall if the cost comparisons, that slide there, are the totals all the same on this graph? Like the example that was shared is from Rob Wagner, Procter & Gamble. The example, steel cost more in Asia than the United States. Do you understand the question?
Okay, and let me see. I understand the question. The steel cost in the United States, percentage-wise, it's not the cost though. It's not absolute cost. The percentage-wise, in North America, the steel cost is less than Asia, right? That's what the question, right?
Yes.
It's not absolute number though. They're just percentage-wise.
Percentage. Okay, so
Yeah,
that,
it's a
Rob, did that
percentage.
clarify?
The thing was like the top is 100%. So the North American project may have cost 150 million versus the Asia project cost 100 million. Is that so? And it's the percentage within there. So what happens is doing it by percentages, it skews how much the actual cost of that, if it's the same program. I know it's hard to do because you don't build the same thing in the same location ever. But I just, go ahead.
Andy, Rob, this is Bill Lewis, and I do want to bring one point to that I've experienced over the last 30 years is one of the things when we go to Asia or we go to Europe or the Middle East, we specify ASTM shapes. And what we have found out that if we let them design it in China, for example, use GB specs or for Europe, we use DIN specs, the cost, especially for steel, is significantly lower. If we go over
because
there,
they have to import our ASTM standard. Got it.
You need to be careful with that.
Yeah,
Okay.
yeah.
I do have 3 more questions in reference to the slide you're on just prior to this, which was slide, I believe, 14. If we can go to 14.
Mm-hmm.
Okay, on that slide deck now, the next question came in from Mike Brewer from Freeport, Micron. I'll get it right. Comparing the man-hour cost, did you account for lower productivity with stick built?
Oh, yes. For stick built, job site, lower productivity for sure, and a much higher productivity in the jobs and the fabrication yard. For example, as I said, and for the structural steel, about the same, but for the piping in the fabrication yard is twice as higher than in the job site.
Okay, Mike, does that answer your question?
Yep. Thank you.
Great, thanks, Mike. I have another one from Paul Hochi from Worley Engineering. Do the cost comparisons include taxes and duties? So the cost comparison block.
And this cost here, including duties. And the duties right now, I know the duties, what, 27%, 25% included.
Okay, so it is included.
Yeah, for the module, 25% duty.
Okay. Paul, does that answer your question, or do you have another question?
Yeah, I guess one other question would be, does it include also like any anti-dumping for steel or anything like that?
No, at this job, when we finish this project, the anti-dumping and the countervailing was not imposed.
Okay, thank you.
But another note is, even as of today, we have two large size shipyards. Our fabrication yard has been waived from anti-dumping and the countervailing as of today.
Thank you.
Andy, great data. As questions come in, if I think it pertains to the slide, it may be easier to just pause for a minute where I can interrupt you. Are you okay with that?
Of course.
Okay, great. Back to you.
Okay, so now the cost. Okay, the man hours are not a cost though. The low one is the cost. Let me go to this slide 15. This is the cost comparison studies we made. I didn't put out too much details on the man hours and the cost, but just for key quantities, I give you another perspective feeling of the size of this project. And this size of the projects, they have 366 numbers of equipment, 3,000 tons of steel, 128,000 feet of piping. And this job, we divide to 18 numbers of pipe rack modules and 61 numbers of process modules. And this study shows that for the stick build, is 100% the only construction cost. But I didn't talk to engineering or manufacturing. It's just only for the construction cost savings. But module is 34%. Stick build is 100%. The module only 34%. And the cost-wise, for the total investment cost, the module is about 15%, construction costs about 45%. I'm sorry, the 15% is the module saving of 15% saving for the total investment cost. And for the module, the construction cost is about 45% saving.
Okay, we do have one question pertaining to going back to percentages versus actual costs or actual units. Is it possible to see the total cost in hours and actual units instead of percentages?
Yeah, the reason I did that purpose
later on, following the presentation.
Yeah, sure. The reason I did it on purpose because those may be proprietary information. I may not want to release that. Yeah. Okay. I'm sorry, but
that is.
I know it's confusing too myself too. When I convert it to the percentage.
No, I knew that would be the answer. It's usually confidentiality of the. Mike Trotto from Owens Corning. That is typically where we ask the presenters to sanitize for confidentiality purposes and disclosure with their clients. So that may be a difficult one to get as you requested.
That's right. Yeah, that's right. And yeah, that's right. I can release name the customers. Okay. So, no question on this slide, and it goes to the next one. The case 3, I said this is a real case. We are closing out this project right now. This is an ethylene glycol projects, and our scope is MEI construction, mechanical electrical instrumentation installation. Okay, pure installation contract. And again, I gave the quantity just to give the perception of the size of the project. The equipment is 438 numbers, and steel 7,000 587 steel tons, and the piping, we're using the quantity as dBs, 471,000 diameter inches. We have 62 numbers of modules. This one I put some man hours in because I just says, okay, I said this, I was get some permit from our project people so I can release this information. For the man hour comparisons, for stick build, original with design, estimate about 40,000 man hours. And for the module, it's about 48,000 man hours because as a module, at least we have to, it takes more effort for the module design itself. Fabrication management for stick build, as just put a none there, but for module will cost us about 48,000 man hours. For the fabrication, the module man hours 1.6 million, and nothing for, of course, we didn't put anything for stick build. The next one's interesting point is for the construction though. For stick build, we estimated originally about 6.5 million, but for the module, the construction, only 4.3 million is about 2.2 million saving of the man hours. Okay. And site management, and for the stick build is 400,000, about 400,000 man hours. For the module, we have 360,000 man hours. So the total man hours, the stick build is about 7 million, and for the module, 6.5 million. So this about in the 500,000 man hours saving for the module in our case, in this case. For the cost wise, again, design, not too much difference. Fabrication is, and procurement efforts, not much difference. And the fabrication, again, all the difference is coming from construction. And the construction, 87.6% for the stick build, and only 58.3% for the module construction. And the total saving is 22.2% saving of the module versus the stick build. Okay, I don't know. I'm sorry. I tried to post a question to our audience here, though. I know this is kind of confusing for my presentation in terms of the numbers and percentage-wise, but if you have any, I'll think about if we can give you some number later on, get any permit from a customer, I would do that.
I'm on mute. Andy, we can capture that through myself and Rob Fisher and Rana Dubrow at the CURT office. So if you have any data that you would like to share following today's event, we can get it back to the audience that's on this line here today. So you can look at that and assess that situation. Thank you.
Yeah.
So Joe, Andy, is this the last slide? Or are you continuing?
No, there's more.
Okay.
He has more, Bill.
I was just going to say, when I look at your cost comparison, and I've been doing modules, for at least 30 plus years, and your data is right in line with what my expectations would be as an owner to see a cost savings. If I get involved early and I have a good execution strategy and I take it all the way through commissioning. Actually, for the mega modules, I'm right here, or maybe I'm expecting a little bit more for when we use smaller modules, like in turnarounds, where I have a process plant shut down and I'm schedule driven to get it back up. I would expect even more savings when I calculate the NPV into that. So I mean, this is right in line with what I've experienced over the last 30 years.
Okay, super. Another thing, all the cases I was talking about, only the construction cases though, saving. And it was not start from the feed design, for example. No, none of them are start from feed design.
Okay, Andy, I do have one question and one statement, if I may, so before we move on. Do you have, this is from Blaine Teixeira. Do you have any comparative data on safety performance for the cases that you've shared in this study?
The safety performances?
Correct. Do you have
Yeah.
anything, I don't know if you have any data or perspectives on safety in reference to what you've shared.
I don't though, because I don't know the comparison between them. Oh, yeah, of course I know the incidents happened for the, for example, this project, this project incident at job site, I know. And I also know the incident, whatever, in the fabrication yard. But I would never predict though, if all the stick built, if everything is stick built, what will be the, accident, safety incident though. That so it's hard for me to judge that.
Okay. Blaine, do you have any other further questions from Bolt Company? Okay, I do have a statement from Rob Wagner, Procter & Gamble. Overall, I see this as significant savings between the two methods. So is it real and do not need for detailed dollars? So I guess that's a statement versus a question, but if you'd like,
Yes.
Andy, I'll let you do that.
I think it's real because, for example, this project, it's a real story too. For the third project, when we just award this contract, though, our competitor has been saying that, hey, guys, how much money had to put on the table for this project? And and I think they were based on the stick built, estimating.
Joe transposed to a noun and the verb. I said, so it is real, not is it real. So it was a statement. Just if you read in the chat, so I'm aligning with what you're saying.
Okay.
I'm just saying, I don't think I need to see the detailed dollars between the two. From a relative perspective, I think you're showing what you need to do, and I'm fine. I'm just trying to.
Okay.
Thank you.
Great. Thank you.
Back to you, Andy.
And Andy, one real quick one, Joe. Sorry, you said these projects they didn't start in that early feed, or they did.
No, this job was not designed based on module though. They started as stick built.
Okay.
So our original proposal was based on stick built, but we convert to module as much as we can. That's what result is.
Yeah. So if they had started in feed, you would expect even better savings.
Even more savings, absolutely. Even more savings. Yeah.
All right. Thank you.
Sure. This one I just introduction of recent, our company is we are EPC company though, and we also have two fabrication yards in China, and this is the one of them, and we have have 100,000 TPA throughput, and those we can do the 456 diameter inch of carbon steel piping and 331,000 diameter inch of the stainless steel piping. We're dry dock about 260 meters and 68 meters. This yard is about 100 kilometers away from South to Shanghai. And we have another yard, which is 3 times the size of the previous one. And this one about 200 kilometers away from our from Shanghai office. Another thing is we're talking about our strategy planning for the for modularization from the company level. And it's our strategy to begin with. All the North American projects is module. No exceptions. No exception, unless the state, unless the state is the union shop state, they may allow modularization. That will be the exception, and we will not attend project. Anyway, we're not, we'll attend that project because of the risk of construction risk we don't want to take. and also we established a modularization group, engineering and design, engineering, procurement, construction group, about 5 years ago. And the leader of the group, the director of the groups, has 40 some plus years of modularization experience, and he has involved in the first ever module in the world. Okay. And the manager of the team, manager of the group, have 13 years of experience. We are target to grow this team to 50 people now. To 50 people, but we right now only about 30 of them. And the criteria, the qualification, minimum qualification is that every one of the staff has to have at least one module experience, module project experience. So another one, I just showed two pictures of the module we built, we designed and built. The right one is a cracking furnace module. Is 40 meters long, 20 meters wide, and 53 meters high. The total weight is about 3,689 tons. And that one on the right is the module, is pipe rack module with the air cooler on the top, 38 meters long, 60 meters wide, and 26 meters high. The weight is 720 tons. And thank you. That's my presentation of today. Hope I can save you some time too. I can some schedule for you guys.
You did fine. We're fine on schedule. I have one last assumption from Robert Wagner, Procter & Gamble. I assume you have tight control on welding standards and weld coupons for confirmed quality. It's a statement.
Oh, yes.
And the answer is yes, correct?
Yeah.
Okay.
Yes.
Rob, any discussion?
Well, it was just I know early days, Procter & Gamble, the experience we had with welding out of China versus what we expect welding. And then we have some industries that require, and especially in Canada, that you have to have weld certifications. So the welders have to be certified. With them being resident outside of North America, I know we had issues within P&G just of one company that Florida versus whether it was in Milwaukee area, and the welds weren't accepted because they didn't have certification and all that. So I have to assume that you've got that all taken care of, or that you're getting the quality of welds that you're looking for as you build these modules. Otherwise, you wouldn't be doing it. You wouldn't be in business, I think. So that's why I said I assume that everything is under control now. We did have, I worked for Pringles for a while, and we had a Chinese-built converter making Pringles. And what we discovered was the vendor that supplied it did not follow any of the ASTM, any of the specifications we gave them. And Joe, I think you were still working here when we tried to burn down Seattle as we fired it up. But so we discovered that back in the early days, 20 years ago almost now, that we have to be very cautious and very watching the specs. So, but it's now established. The industry is very much established to do modular and deliver to North America. So I feel comfortable about that. That's more a statement. Thanks.
Thanks for that.
Thank you. Yeah, thank you.
Yeah, I got a couple questions, Joe.
Wait a second, Bill. Let me open it up to the audience first. Are there any questions? And then I'm going to go to Bill Lewis, and then we'll end the questions for Andy at that time. But I do want to take a minute for any questions coming in from the main audience, please. Just unmute your mic and state your name and company. Okay, Bill, I'll turn it to your questions. If we can try to make them crisp, I appreciate it.
Okay, yeah, the first one was with working with licensors, Andy, in the design. I have found that if you buy a lot of licensing technology, that they have been a little bit difficult to bring along. What's your, what's your experience with that, working with licensors?
Yeah, we have been engaged with so most of the licenses in the world. For example, just for the cracking furnace per se, we did, and Lomas is one of them, and we have Lindy. We have, that's the two I remembered. And for the PDH, for example, we have UOP as licensure, and we're doing our the MTO project. We have shared we require licensing from Shell and GE, and we've been doing it with all the licensors, almost most of the major licensed technology supplier in the world. And again, another thing is that Jens, another question about the fabrication though. Our fabrication yard has been qualified and by Shell, by BSF, and also by ExxonMobil too.
Mm-hmm. So I guess my question with the licensor, Andy, was, are the licensors more receptive to a modularization strategy? They used to always push back on that, but are they better now?
Yeah, I do. For example, UOP though, again, I'm talking PDH, that project, PDH though. UOP has been specifically asking us to collaborate with them to modularize their regeneration units. It's a very high, tall structural steel with the vessels in it, and one has to help them to patent the, that's modularization design.
Okay. The last question I had is, you're when you're dealing with barge or ship, transportation methods, when do you guys usually engage the marine surveyor, the marine engineer for release design?
In the feasibility study.
Okay.
We engage with our marine designer at that time. And the only difficult part is that you have to find it's a specific ship you are hiring, used it for particular modules, because the wave action for each stiffness of the the barge are different then. So that's what caused it difficult for the design at early stage, but eventually we should get that number done. Yeah, that's the challenge part. That's why we want to engage them early.
All right. Thank you.
Andy, thank you so much. It was a lot of great details in the cost area, and folks have been asking for that for a while. So thank you so much for being able to take time today and share in a sanitized way the percentages and the information that you did. Let's give Andy a virtual applause. I'm sorry I missed Jeff Holtz earlier. So Jeff, if you're still online, you as well. But Andy, thank you. Rajiv,
thank you. Thank you. Okay.
And our next presenter is Rajiv Sarbarharwal. And if you could request control and share your PowerPoint, we can walk you through it if you like. Just let us know.
Hey, yep. Joe, let me know if you see my screen.
I see your screen, and all you have to do is put it in presentation
I'm putting
mode.
in the presentation mode. Just give me a sec.
And we see you clear, and it looks great.
Wonderful.
Okay. Why don't you give a brief background about you and your company, and then we can go right into your slides.
Wonderful. Thanks.
Thanks, you.
Good afternoon, all. Hope you guys are doing well and enjoying the presentations on this as I am. I take this opportunity, first of all, thanks to the CURT organization for organizing such a conference, and to Joe and Bill for providing us an opportunity to share our experience, knowledge about the quality advantages of modular construction. Yeah, I would also like to thank my colleagues from Asia and the project quality manager for the BP Mad Dog 2, for the BP Cassia, and the GCGV project quality manager for providing their inputs into this presentation. Working on the two different continents in Asia, where I was responsible for supporting China, Korea, and India, and basically supporting the fabrication, working on the QA/QC side for the clients, and further in North America, where supporting the Canada and US for major projects or major capital projects. So I had been very lucky to be involved in multiple projects having a modular construction. I work for the Bureau Veritas as a Director of Business Development for North America, supporting the Global Capital Project. Those who don't know Bureau Veritas, the Bureau Veritas is a global leader in the TIC industry, which is testing, inspection, and certification. With a presence in around 140 countries with 76,000 employees, we serve the sectors from oil and gas, building, construction, to the aerospace. Supporting all these areas had been basically one of the area in oil and gas we had been seeing a lot of construction and fabrication globally at the various modular yards. The modular construction is becoming quite popular in various industries, including oil and gas, housing, construction industry. In late 90s, I remember that when I was supporting the Asian businesses, there was most of the work we were doing was supporting on the offshore projects. And with a lot of success with the offshore project, or basically seeing some of the projects which are located in a very difficult atmosphere, where around the year, things are not possible to do the construction. So those were the early, I think, late 90s, where most of the people used to utilize the modular construction. But as we approached and people started realizing the benefit of the modular construction, they moved around, they found lot of benefit of modular construction. I myself is a huge fan, or basically have witnessed a lot of successful modular project. And today my presentation is focused on specific area of modular construction, that is the quality aspect of modular construction, and how basically developing a right strategy for obtaining the best quality out of modularization. A typical modular construction project contains around 5 major steps. Engineering, specific engineering to the modules, fabrication of those modules at the yards, which are located away from the site, and most of the times from in the different countries too. And then for a transportation strategy for shifting those modules, maybe through sea and special requirement through the land transportation, and a site installation, putting up all those modules into a fixed plant, into this fixing all those modules into the black box and getting into the fixed plant, and finally commissioning and ready for it. One of the major difference from stick build and the modular construction in the terms of steps involved, in addition to fabrication and modularization, is the precise transportation and site installation strategy. Special infrastructure is needed many times due to the weight and width of the modules to transport on the land. And I don't know, many of you might have basically recently been towards the Gregory, would have seen that a long hauling roads specifically built and constructed to support the project. That's some of the additional things which are not generally required too much in the stick build, but required for the modular construction. As described by my friends earlier presenters, that there are various advantages of modular construction, and the prominent being at the improved quality of the fabrication, increasing the overall safety, reduction in the cost of the project, and reduction in the schedule of the project. And last not the least is the lower impact on the environment. So typically, if I put all these advantages into 3 legs of the project where the decisions are made, whether you want to go as stick build or the modular construction, we have seen that these decisions around schedule, cost, and quality, not only a single factor, but all 3 factors combined play a very, very important role in making the decisions to go which way you want to go and what is the best for your project, because not one size fit for all. As every other process, modular construction does have its challenges, and if these challenges are not addressed well or mitigated well, then we may lose a lot of benefit what we perceive while making a decision whether to go to module or stick built thing. One of the few of the challenges, if I put it around, is the engineering challenges. And engineering challenges is made in other ways, is also like, okay, I have witnessed myself around that we were working and doing UIQC at the yard and found that the yard fabrication was utilizing the revision 2 of the drawing, and the engineering has already issued the revision 3. So that's somewhat basically those confusions where the communication is not very correct leads to issues. Documentation controls can be a big issue because these yards they support global projects, and each projects have different documentation control requirements. If those things are not mitigated rightly, so they can lead to issue. And one of the major area we see that with respect to towards the quality is communication and coordination in controlling the sequence of fabrication. We all realize that in order to get the benefit of the modular construction, lot of activities are moving in parallel. And sequencing them is very, very important to avoid any challenges coming at the later stage. So one of the prime examples come to my mind is, again, we were working on a project which was requiring a PFP, and then the insulation was also parallelly moving. So during the inspection, it found that there was some of the damage to the PFP line, and then those damages was repaired, and it was curing. While it was curing, the other team, which was already doing the insulation, they already completed the insulation, and when we performed a non-destructive testing, it was found that there was issue. And we found that the curing was not fully done before the insulation was already put on it. So this is a basic example. Again, if the sequences are not done correctly, it can lead to big problems. In this particular case, this was due to good quality control practices and quality assurance. This was captured and rectified at early stages and this avoided any major incident at the later stage. So coordination, again, is a major key for any of the modular construction. There are various parameters which can enhance the quality of fabrication at the yards and can broadly be categorized in 3 different areas. So typically, to get the maximized benefit of the modular construction, my experience, and I think in our experience, 3 major areas plays the maximum role. One is the location. So when I'm saying location, I'm saying about physical location, which is directly related to the safety and quality culture of that country, that location. Because we see that in different countries, the concept of quality and cultures are different. So that has to be very much taken into consideration when we are putting our modularization strategy and controlling the quality of those. And second area becomes around the process integration. A process is typically establishing the right quality assurance program for the project. And that has to consider again into that what is the culture of quality, what are the safety cultures, and how the communication between those are able to put. And finally, both of these process and location or the cultural issue, the quality culture cannot be accomplished without having the right resources or the manpower. So typically identifying and retaining the right manpower will help us to accomplish both of these. Further in my presentation, let's deeply dig down in all 3 parameters, how they can affect the quality and how controlling them we can achieve the maximum from out of the modular construction. So here, the first is the yard location. Here, the yard location refers to geography, culture, and environment of the yard. Understanding the strength and challenges of the location of the yard is very important to develop the right quality strategy. There are various specific characteristics of each location, which needs to understand at an early stage, which we'll be talking further around. If we see the majority of global fabrication yards are located all over the world. In the past basically, I think past decade and a half, I had seen China getting a lot of attention and keeping the game up in terms of quality, coming back. Korea had been the one which mastered the art of producing the modular construction. And all these yards, if you see, basically yards in China, Korea, Thailand, Malaysia, Indonesia, India, Mexico, US, and UAE, all of, as Bureau Veritas, we have been present at all of these yards and see that these are so global and cater to all the various global projects in different countries. So modular construction is a global need, and these yards support the project all over the world. So what does that mean for me? So for me or for my project, these yards are exposed to the various design standards and manufacturing standards. These yards are exposed to various regulation of the client countries. So we have to consider these two phenomena into our strategy to build up the strategy to ensuring the quality out of the modular yards. So we have to see what are the various risks and put up a mitigation plan through those areas. So if I define quality, so quality is a very subjective term. Quality is the degree to which an object, entity, process, product, or services satisfy a specified set of attributes. Or in a simple term, quality is the degree to which a set of inherent characteristics fulfill the requirement. And as it is a very subjective term for which each person, region, sector has their own definition. Therefore, in order to do a successful project, ensuring the right quality, we need to define our quality and safety needs. We have to keep in mind these yards are catering to the global design standards and all. So firstly, if I see the first parameter, the local safety and quality culture. So this is very, very important to keep in mind how the local, where the yards are or the yard management perceive the quality and safety. So we have seen, implemented and seen a lot of success when at an early stage of the project, an assessment of the resource quality and safety culture is done. And that gives us an opportunity where I have contracted the yard stands in terms of quality and safety. And then what is my quality needs will help me to do that gap analysis and prepare a specific training program in terms of quality and safety for that specific yard. Second area, again, we see that since these yards are exposed to various international manufacturing standards, as my friends talked about, they basically use the ASME, they use the EN standard, they even used different material standards too, from a basic GB standards, if you see on ASTM standards or the EN. So typically these yards are very much used to various standards, various materials. So for my project, we need to take this into consideration and integrate the change management process, mitigating these design processes. We need to reduce the interfaces between those designs and with the yards. So typically, again, doing the yard past experience, assessing their past experience on which type of designs or which countries they have supplied, help us to ensure that we are able to put a right process in place, ensuring that they meet my project needs. If it is for the US, developed as per ASME. So typically that's where I need. So then putting up that strategy to mitigate these, engineering process helps. And one of the major issues we see, whether it's going in Asia, whether it's going in South America or other part, is sometimes a language is a big barrier. So projects employ highly skilled to semi-skilled persons in terms of quality, which may or may not be fluent in English, which possesses a risk to understand and meet the expectation of the project. So we need to put up, again, a strategy in the place or the communication process in place to ensure and mitigate this.
Rajiv, if I may ask a question, it's a good timing for it. The question came in, are most of these global yards familiar with American design standards such as ASME, ANSI, NFPA, NEC, and et cetera? In your experience, are these yards that you're referring to familiar with the American design factors?
Typically, it's a very interesting question and a great one. So we saw that in the last 30 years around, there is a lot of understanding went around globally. We saw that earlier in 90s. This came to Korea, where earlier their understanding of the ASME or the basically American standard was not much. But as they got into the project, and the project led those changes to support and integrate their engineering team to understand those standards, help them. And similarly, in the last 10 and 15 to 20 years, we have seen the same phase in China too. Now we see most of these yards have a fairly good understanding. But again, at the same time, we need to assess those yards' capabilities and understanding of the past, because with so many number of yards, that is the prime area when we are engaging the yard, or if it has been engaged, we need to do that assessment of their understanding. Because one thing is yard past experience on the different design standards, but second thing is the yard current team understanding of the design standard. They are in terms same and are different too. So, but just a simple answer to that question, yes, we are seeing a lot of maturity coming to various yards to develop and understand the various standards. Does that answer that question?
As well. Thank you for sharing that. I appreciate that. Also, Rob Wagner's provided a comment. I'll let everybody look at chat. It's a testimonial of what his experience has been in this area as well. Rajiv, back to you.
Okay. Let me go back. So we saw that basically some of the challenges on the location side of the yard. And one of the prime examples come to me in the communication side is, it was an incident where I was inspecting the yard in Asia. And on the first visit, when we were trying to identify the materials, we have to issue NCR. Generally, issuing the NCR on the first visit is not very common. But what we found in this specific case was the material certificates were not available at that with the yard or basically at the shop, and neither the marking and traceability on the pipes were not there. So typically, it was why this was a big non-acceptance. And when we tried to dig down on the issue, and we found that the local standard practices was not there. The yard was very much used to supporting the local projects, and for them, all the materials coming, they were trying to segregate and put them back into fabrication. They never faces such problem. So typically, the local practice was one of the big issue. And secondly, the material management process was not fully established. So that again was captured again at early stage, and we have to help them in developing those processes and implement those processes so that in future things goes well. The quality team, it says that the quality team need to consider the local habit when they are defining the quality control process for the project. In summary, if we see the location, that we saw that how important is to understand the yard location in developing a right quality strategy. Now, if we see the next step after controlling the culture of quality of the yard, the next step is putting up a process. So process in terms of quality refers to quality assurance. So in a quality, we typically see that there are two ways to control the quality, is one through the process, which is a quality assurance, and one through reconfirming the steps, which is a quality control. So the process FS2 is putting up a system in place following which provides a standard result for which the system was designed by the stakeholders of the location. So two prime thing is that system was designed by those stakeholders with a certain expectation, and that is typically the process. Now, what happens in the modular construction when we are talking on a global project is that we have a multiple stakeholders. So the yard is not the only stakeholders left. So if I see that in a typical modular project, there is an operator, there is an EPC, and there is a yard. So these three stakeholders, they have their own quality assurance and quality control processes. They have their own quality goal and quality policies. So thinking about whether we have three different sets of expectation, can we achieve a right project quality? No. So what do we need to do? We have to do this integration, developing a common goal, one system, one execution plan, and one organization. So these three combined will help us in achieving the right quality out of fabrication at those modular yards. So if I see that.
I do have a question. It pertains to that.
Go ahead.
Do you experience much turnover with your quality personnel supporting the owner quality assurance validation step? So in that big circle, you talk about organization and resources. Do you experience much turnover with your quality personnel supporting the owner quality assurance validation step? That's from
Great.
Bill Lewis, Sabic Company.
Great question. And I think I have basically, because that is the third pillar of quality. The pillar one was location. Pillar two was, again, is a process where we are talking about, and pillar three, it will come on the resources. So as we will move further, it will answer your question, right? Okay, Jeff?
Thank you, yeah.
Okay, no problem, right. So typically we see that we need to have an integrated process. And how do the solutions sounds like? So carrying out a gap analysis of all three processes, so developing a quality and HSE system that is basically looking at the stakeholders' quality and HSE expectation and developing a single plans helps to conduct and control the process. One team, one system, one management process helps. Then putting up a one process and defining the responsibilities for each stakeholders. So as we saw at the first slides around, that the generally or the decision to do the modularization based on the benefit of cost, schedule, and quality. And if we can define these three stakeholders process, then the responsibilities well helps. In one of the big project, I think it was the project we just completed, had a 400,000 metric tons of construction at 8 yards. And there, one of the learning around was that, okay, the responsibilities should be clearly defined. Yard, for example, if is responsible for the quality of the manufacturing, and then EPC and the owner operator, instead of putting a two independent organization to ensure the quality, do an integrated quality control approach, nominating a one company. In project Yamal LNG, again, where we took this approach and wherein Bureau Veritas worked on behalf of the EPC and the owner operator as a single company supporting all the yard fabrication QC. So typically that's the second area where we are able to put a single process and single responsibilities are defined between the three stakeholders. And finally, looking and reviewing the constantly and constant improvement, implementing the single process will help us to capture the benefit of the process. So now we captured the risk of location, and we saw that the benefit of integrating the quality assurance system. So the next best factor, I think the next big factors without which these two parameters will not be effective is managing the resources who will be responsible for the final implementing and ensuring the quality. So the last and the most important element in ensuring the quality is the resources, that is the persons involved in QA and QC of the yard fabrication. So in an ideal world, a right process or the quality system should result in right product. But ensuring the quality through the constant checks and balances is quite important. And this is done through the quality control. So we covered the quality assurance through the process, and now the quality control through the manpower or resources. So this is the resource component of the quality control, is to ensure that nothing goes wrong inadvertently. And this is typically organization chart, if you see on the screen, for the yard quality control. So it is led by the yard quality control manager, or basically who is responsible independently and report to the management, followed with the support from the quality leads for each of the subject matter SMEs, and further implementing the resources, discipline inspectors or the discipline people around to ensure the quality of the yard. So coming back to Joe, your question, we conducted a study looking at the 10 projects, 10 modular construction project in various geography. It was typically 3 different areas where we looked at. And the study was done to find out the impact and the reason of quality control resources leaving the project, or basically movement of the quality control resources. So the top reason we were found, which was, okay, we didn't thought before that, was that the resources get demoralized or basically frustrated due to the lack of understanding of a project quality expectation. Many a times with the multiple stakeholders, the message to the resources who are responsible for the quality doesn't resonate well. And they hear a different tones and expectation of quality, which led to a large job dissatisfaction, and people start leaving at some point of the project. And second was lack of incentives to continue till end of the project. And these were the 2 big reasons what we found around, in other than basically what was the issues with the yard, whether the welding procedures was, there was a lot of issues with the welding procedure, those areas that depends upon, time and depending upon yard and location, different areas. So to develop a highly motivated organization of quality resources, a number of initiatives were implemented. After the studies, Bureau Veritas, with our clients, we implemented a lot of steps around. Since most of the modular construction is aimed at international project, so the best strategy we saw, that selection and retention of the right resources to support the project, was selecting a pool of local and expat resources to ensure the quality. So when we say expat, many times they were from the country where the project is located. And they are the best people to know what the expectation of quality at that place is. And mixing them, bringing them with the quality resources at the yard has helped to develop a single integrated quality control process. And once we have what is expected and what is in the past experience, so putting that gap analysis and developing a good induction training program for the resources helped a lot. So this training process, everybody, whether it's a local or expat, had to go through this training process before getting into the workload. It helps them to understand the project expectation, their responsibilities, and what basically they will be able to do, which leads to a lot of job satisfaction for them and helped a lot. And second area, we saw that many times it is, more on these projects being global and manpower is not very local because yards are located in the remote part of the locations to take advantages of the shipping routes and others. So most of the quality resources working at those yards either are coming from some far distant or nearby distance, or typically many times from different countries. And when we are doing our project, we are even putting a tax pad. So many times what is ignored by the owner operator was looking at right living condition for the resources. So finding the right living condition for the resources, better place to live, fooding issues, and the commute from the location to the yards and vice versa helped the resources or the basically personnel responsible for the quality to leave their any stress out back at the hotel or the home and devote the full attention to the quality at the site. And second area was incentive. I know, like you guys and me, we work quite, we are quite happy and are working every day and day. And might not need an incentive, but I think all of us need some incentive to do a better and better job. And that's where we realized it, and introducing an incentive strategy at a very early stage for the quality resources helped us to mitigate that. So what we did was, every week a quality resource or the quality person is working, he or she accumulate some number of bonus hours for each week. And these bonus hours get accumulated and will be paid once the project is finished. So the people are accumulating a commercial benefit. They get motivated that these benefits will be passed on to them. And it also helps to retain the resources so that when project is 50-60% completed, we do not start losing the resources. That was sometime very common phenomena which we were seeing in various countries and various parts of it. So that helped it. And since these projects are 12 to 24 to 36 months of fabrication, so imagine that much of incentive they are building up, and they will have a very, very less incentive to move out of the project. And finally, as all of us, we need to be recognized. We implemented various recognition programs with the support from the client and the yard, like the basically safety man of the month, safety lead of the month, quality lead of the month. So in this way, people were quite remaining competitive, and they were quite motivated to achieve the goal for our quality goals or for the yard. And finally, if we have selected the right people, trained them rightly, taken care of them, and we need to continuously do the trainings again and again, repeatedly tell them maybe 5 minutes for the safety every day, and add 5 minutes for the quality every day. So that giving a repeat, information, or basically sharing the experiences and doing a continuous upgradation leads to a great project around. And finally, since these resources that are from outside are from internationally, so developing a good rotation plan for the resources help them. Like many times we see that 3 weeks on and 1 week off, and 4 weeks on and 2 weeks off. It depends upon where we are doing the project, how the situations are, and then developing that will be helps to the project. In a recent project we were doing in Mexico for a big offshore project, and typically we saw that then the COVID situation went bad around, so we brought those resources back to the US, help them to take some time off during the time when the situation at the yards get better. So typically, I feel the resources plays a very, very important role. As a people of ensuring the qualities plays a very important role, and we need to ensure all three parameters: location, which is the culture; the process, which is the quality assurance; and the people, which is quality culture. So finally, to summarize that, consider all the limitation of the yard in our strategy. Integrate the QA/QC process in the project quality strategy, and develop a dedicated plan for the quality resources. If we are able to capture 3 of these parameters, then yes, we are ready for obtaining the best quality from the modular construction. And as Bureau Veritas, at every time we are involved in more than 8 to 10 projects, the modular construction, with the presence in all over the world. At this moment, again, I'm already working on 4 North American capital projects utilizing the modular construction. I see a lot of benefit of modular construction. And yeah, thanks for this.
Getting it off of mute. Rajiv, thank you very much. I have no more questions on chat box, or if I did miss any, if you have any questions from the audience, unmute your phone, state your company and name and your question. I greatly appreciate it. We have a few minutes for questions. Andy, if you're on deck, if you can request presentation and share your presentation. And again, are there any questions for Rajiv? If not, Rajiv, thank you so much for that data. It's always good to hear about quality and the systems that we're seeing around the globe. So thank you very much. I appreciate it.
Thanks a lot for this.
Thank you.
Thanks, Rajiv.
Hey, Andy, I see your slide deck. Can we check your volume?
Okay, can you hear me?
Yes, I can.
Okay, great.
Okay. Andy, if you could, Andy's from ModSmart, and he's come in working with ModSmart now as a principal engineer. And Andy, if you go ahead and take control, I greatly appreciate it.
Okay, great. Good afternoon, ladies and gentlemen. I'm Andy G. It's my honor to represent ModSmart, giving our audience a presentation. My presentation topic is module area design and COG weight balance planning consideration. Before I'm moving to my topic, because I'm a new face in this event, I would like to introduce myself. First, I began working in the offshore industry in the early 2000s, and mainly involved in subsea pipeline, riser design, subsea equipment installation. I had been working for major offshore projects, including BP Thunder Horse, Shell Perdido project, Chevron project, when I was in our big offshore contract like Technip and Acergy. Right now it's merged with the called Subsea 7. During the past 10 years, I worked for Bechtel OG&C offshore group. My work has focused on multiple LNG projects and mainly responsible for the module design, inland or ocean module transportation, module yard evaluation, module we call it MOF, which is called the MOF module offloading facility, and the module we call the safe fastening and tie down design, and also I perform a lot of vessel barge qualification evaluation. Major EPC LNG project and chemical plant projects I involved includes Shell Pennsylvania Chemicals, Chevron Wheatstone project, QC LNG project, and AP LNG project. These 3 LNG projects are located in Australia. Right now, I'm an engineer lead at ModSmart, and I have a Texas PE license. I believe right now we can provide our client all module design, fabrication, transportation, execution, and management related or consulting services. Okay, then now let me move to our today's presentation. Okay, introduce down. Okay. Recent, we can say recent 20 years, many LNG or chemical plants have been built around the world, especially in Australia, US, and Canada. Due to construction cost consideration, most of them have been designed as a module and fabricated in different module yards. After module fabrication complete, they are transported through ocean or inland river to job site for final installation and test. Therefore, module weight and COG control become more and more important in different phases of module control management. We Mod Smart have following philosophy to handle this situation. A strategy evaluation and planning based on the content export, practical experience, and development and module projects. We have working on modularization for many projects from the pre-feed, feed, detail engineer, fabrication, and final installation. Therefore, we have know-how knowledges, and also we have good connections with many experienced experts in this area. So maintain an integrated, collaborative environment through partnering with the clients and associated project teams. Satisfy clients, keeping healthy working environment and finding right solution is our goal. So assess and evaluate each project based on the client specifications, specs, and key drivers to find the optimal modularization strategy. We call the one blueprint does not satisfy. As each project has own characters and complexity. For example, the project is brownfield or greenfield. We will provide different strategy. We will face different challenges. Maybe, for example, the brownfield may have more issues for construction and transportation due to the job site and existing facility limits. We need to find out where bottleneck is and make right decision before the project is initiated. At this stage, module size and configurations are governed. So we see a single solution cannot cover all. We have to, based on specific module design or facility, give you a right solution. Rationalize the hierarchy of control throughout the project life cycle, thereby delivering improvements in project performance, safety, schedule, risk reduction, and cost competitiveness to the client. I will talk about more details regarding the module weight control process in the next slide. And transcending to overall advantages through Mod-Smart's agility, gig basis, low cost, and fast pace, integrated management, and extensive global network of qualified personnel, resources, and facilities. As we have dealt with so many module-related projects, our experts understood the working process and how to provide specific construction and feasible solution for each project. Here is our Mod-Smart weight control and COG management approach. In phase of the pre-feed, sometimes called the front-end loading, we need to decide estimate module weight based on previous module design basis or experience. The initial estimated weight and size are very critical to the project. It will impact module field layout, module yard selection, transportation approach, module offloading facility design, and module yard key capacity. Also, the shipping vessel and barge selection. As well, the job site lifting equipment selection and arrangement also related to this first earlier stage. Based on the above considered factors, if the maximum module weight is decided, we need to control the final module weight, not exceeding this limit. Otherwise, it will create a big issue during the EPC phase. Finally, this will impact project total cost. We have so many lessons learned in this module weight control. I can give you some example in the previous project. All modules have planned to transport it by ocean vessels. Before vessel sails, module layout and the loading sequences on vessel were specified already. Vessel shipping conditions have been confirmed and verified. That means this vessel is qualified. And also the vessel stability, vessel strength, integrity check, and the vessel ballast plan, everything is checked. If the module final measured weight and the COG position exceeds the tolerance margin, which was given to the shipping company before, engineering rework, I mean this subcontract shipping company, will create a lot of rework for them. They have performed a lot of engineering again, especially for identified critical modules or very heavy modules. The weight is very, very important. So the module weight beyond specified tolerance will resulting in cost increase and sometimes definitely impact shipping schedule and delay the project. So module weight control engineer or personnel play in the important role in this process. They should, okay, this person, I mean the weight control person, should understand whole module design process, fabrication process, and dealing the detailing approach and having good communication skills with different disciplines, such as we have a structure engineering design group, we have processing group, and also we have subcontract detailing fabrication fabricator, and so on. So this guy is better in the whole process and have more experience and have good, relationship with all these disciplines. So if you have any questions or need some feedback from different discipline, so you can get all the information you need, but you have to know what you need, so all the discipline can provide to you. Okay, this is a map. We can see our approach. For example, early identify cation module weight is definitely this early stage. It's very important. And then we're going to update our report during the feed, or especially for the EPC phase, we're going to update our weight report monthly. And also we going to develop engineered weight control process. Okay, when we get to everything done, we're going to decide all the module, for example, installation method, like what's the vessel going to use, or barge, or transportation, all this related information, we're going to decide it, okay? When this project, I mean the module complete, we're going to validate the weight, and COG, definitely going to validate based on compared to our calculated the weight and the COG. If there are definitely there's a difference, but we have to make sure it's better the measured the weight, we call the final weight, is within our tolerance margin. If not, we have to make sure if what's the limits beyond our tolerance. If significant difference, for example, for the huge or heavy modules, definitely we need to take quick the actions to make sure all the following process can follow. For example, we can give this our report to our shipping company or the module yard or the fabrication job site. Make sure they understand any impact on this difference. When everything is done, we're definitely going to hand over all the weight control the report to the our management, and we'll get ready for the shipping, basically.
Andy, I have received the question. The last slide.
Okay.
Do you recommend a weight control engineer for all model projects?
Mm-hmm.
So the answer is yes.
Yeah, we have to find the right person to do this kind of work. Okay. Otherwise, if without experience, they don't know which discipline they're going to communicate with them. They got a lot of headache later. You have to collect the right information, make sure they can use. We have basically each company has their own program. They know how to collect all the data and get the final right weight. Yeah.
Excellent. Thank you. Appreciate it.
Mm-hmm. Okay. This is our this slide showing the weight control. We call it the cycle. You can see from the feed to final load phase. Okay, each phase has different weight. We call it contingency tolerance. The tolerance will change from you can see from the very large number, about 25%, to a very small number, maybe the final load out about 1 to 3%. This is our target, basically. Okay. Generally speaking, the final calculated weight will be close to the validated weight on the module yard. The weight contingency limits provided in the table definitely is recommended based on our industry practice and engineering experience. You can see based on the phase, we can have a feed phase. We have the 30 model review, 50 model review, 90 model review, and also we can get the final calculated weight. Basically, this is this phase. Okay, we already receive all the vendors, the supplier weight, or all the piping weight, all the equipment weight at this stage, basically. But when we see in the phase of 30%, for example, we don't have a lot of weight information. This weight we call estimated equipment weight based on we have some kind of, for example, each company or project has their own date. We can get this information. We can combine it. We get the rough number weight. Okay. When we got a 50% model review, we, as a design engineer, they already create the model. For example, like a 3D model, where we show all the equipment structure. Basically, we have structural steel and some kind of equipment, piping, processing piping, whatever. They already on in this model. So, but it's not complete, basically. When we moving further, that means 90% model review is a more weight accurate. We already get more detailed, more weight information. Okay, so that means that we can see the weight contingency is different, and become the number you can see is smaller. That means that we got more accurate information, so we get more accurate weight of module. Also, the COG was, we can talk about the COG. Also, each company has their own program. Okay, they can also get the COG, not only weighted information. Okay. Finally, when we the module complete in the module yard, so we're going to doing the final weight consider using the different method to calibrate our calculated, we call it calculated module weight. Okay, next. Okay, this slide gave us showing some poor, we call it poor weight control planning. Okay, there you can see the photo. The top left, this is called a top side structure, and this is this offshore project basically. You can see it's a heavy weight, maybe over 10,000 metric ton. You can see the module load on the ship. Everything looks normal. Everything looks going well. But you can see the photo is this vessel is called capsized. It definitely is a disaster for our client, for for the project. Definitely delay. If you lost the module, you're going to delay the schedule. Definitely, there's significant impact on our project. The main reason for this, you can see like the module weight control. There are something goes wrong. For example, COG, or it's called COG. Basically, we have the plan COG. It's called the COG in the XY plan location. Also, we have what we call the vertical VCG. So when before the vessel sailing, we already done our called stability analysis for the ship around the route. We already consider all the wind, all the scenario, load scenario, make sure shipping the module safely. Unfortunately, this went wrong. You can see there's a disaster. And also for the bottom, left bottom, the photo, there's a called topside lifting. I'm not sure you can see them clearly or not. This you can see the module, the tilting. Okay, that means definitely when we design the rigging, lifting plan, we have prepared the plan based on the COG location. Okay, if something COG, the position beyond the limits, okay, you can cause the problem. That means when you're lifting up, the module definitely going to tilt. If this happens, it's hard for the installer to put this module on the right position. It's very, very difficult. You have to re-rigging, so this causes big problem. So that means for the middle one, like we call the unorthodox practice, this means when we doing the module weight control, okay, we also select, for example, what's loading on or the load off the keys. Okay, if we select the wrong key because of high risk, say for example, this picture showing we got a wrong, basically not suitable for this loading or load off the operation. Fortunately, it's not went wrong, but this potential high risk. So when we're doing all the planning, we have to make sure all the module weight definitely related to this, not only itself, also they go to impact the what I call the key, or we also called mall facility selection. Make sure we select right key. For the right bottom picture, where they called you can see the crane collapse. Okay, this is related to the COG. So if you're lifting this up, if, for example, the weight exceeds the current capacity, definitely cause the current collapse, or the COG position is not right, it's going to happen. So that's why we got planning control, weight control planning is very, very important during the project or process. Here is another, we call it poor weight control planning. We have something happened. You can see basically they are related to the transport on inland. So we use SPMT to carry all the structure. And you can see if you're something, the weight is not right, okay, you can see something happened. That means we have a very poor the weight control, maybe very poor COG. We have a poor transport plans, and also if you are key in the near the sea, we have mooring line plan. We have to make sure provide the right mooring line, and we have make sure the bollard along the quay is capacity, whatever, you have to check it. So otherwise, you're gonna cause problem. If there are some weather condition change, for example, they're going to cause a lot of challenges, okay. Okay, this is this slide. I'm going to introduce method of module transport and installation considerations. Module transport mainly includes three methods. One we call land transport. Second is called ocean transport, and the third one we call inland river transport. For land transport, basically truck can transport a small size and a lightweight module or some equipment. And definitely the SPMT can transfer the module between the module yard and the job site. For ocean transport, different types of vessel can be have to consider, depends on the module size, weight, configurations, and also we have to consider the vessel and the ship availability during that time. For the vessel, for example, for the ocean transportation, we have different type of vessel. For example, we have called a roll on, roll off vessel. We also have called a heavy lift vessel. This vessel have its own lifting equipment. We have called self-propelled barge, and have a submersible vessel. Maybe some picture we can see the showing this like a right. They are big, like a big submersible vessel. Okay. And this one, middle one, we call ship, or we call self-propelled barge. In fact, this is a ship, okay? We even call it barge. So the barge, definitely, we prefer use barge because the cost consideration. But if a shipping time is more critical, or the shipping route is the weather condition, we can say very, very severe. So the ship is a better solution or option for the module transportation. So this is a shipping plan, we call the voyage plan, and vessel availability. During the shipping period, we need to consider at a stage like a pre-feed or feed, beginning of the EPC stage. any change, for example, you are changing, for example, from shape to bar or from bar to shape, this definitely is going to big impact on the project cost. Second one we call the inland river transport. For some project in US, we have called inland river transport. Basically, we have the module yard or fabrication yard in US, and we're going to use our barge, okay, transport all the module. If any module is transporting the river, around the river, the module height, okay, is a very critical factor when we decide transporting along the river, okay, because the barge going to maybe go through underneath the bridge, there's a height limit. So when you decide the inland river transport your module, you have to make sure you have to have all the clearance information. Make sure your design, the height of the module cannot exceed the limits. Otherwise, you cannot get your module go through underneath the bridge. The collision of the bridge is going to be very, very risky or very dangerous. Okay, after talking about transport method, I need to point out another important consideration is infrastructure facility capacity. In other words, we call it module yard or MOF capacity. At the earliest module design phase, key feasibility study for proposed module yards need to be evaluated based on module size, weight, water depth at key loading capacity, proposed vessel or the barge. We have know the boiler, for example, boiler locations and the capacity, as well as tidal data. You have to collect all the information, make sure you are proposed the yard or module yard or key is suitable for your module transportation. Do you have any question? We're going to move on to next.
No questions on chat at this time,
Okay.
Andy.
This is given a very good example, well planned. You can see all the operation goes smoothly, safely. So for our industry good practice, we have to follow, for example, prepare the storage plan, which show module location on the ship or barge based on the installation sequence and the module size, as well as a COG location. We will need to prepare a good lifting plan and transportation plan, heavy haul plan, basically for SPMT transport, and also ballasting plan, okay, during the module loadout and the load in. And also need to consider the ballasting plan during the sailing condition. And also we need to consider sometimes, the module fabricated in the, not in the US, for example, you have to have, we call it foreign water. We have ballast water for if we use a foreign water, we can make sure is not use the foreign water. You cannot pump out in the job site, basically. So when you're doing the ballasting plan, you have to make sure which tank, for example, ballast tank you're going to use, may go sealed with the foreign water, you cannot use it. So you have to prepare good ballast plan. And also, you need to prepare very good mooring plan. This slide can show in, we have module, different configurations. You can see some of them are very wide and some of them very tall, slender. It's a very tall module. You can see we call it vertical COG is going to be governed. So we need to pay a special attention to this type of module during the lifting and the transportation operation. Basically, this is a stability code issue, our main concern for very tall, very high COG. Okay, this is called module validation method. When we fabricated the module down, finished, so we need to measure the module weight. So we have three types of module weight validation methods. First method called a load cell for low, we call lifting on, lift off operation. You can see the sample load cell equipment is shown on the slides. The load cell will be connected to the lifting point based on the reading data, total weight, module weight, and the COG position can be received or from the reading data. Okay, we're going to calculate and we can get the weight information. Second validation method we call the load cell banks. And this load cell going to be placed at the spawn point. After we have to lifting the module from the support by crane, or we can use the SPMT and then lower the module on the support. Load cell will send the reading data to the computer terminal for process, and then we can get the COG, basically we can get the COG position. The third one, you can see we call calibrated gauges on the SPMT. We have the heavy haul, basically a lot of heavy haul use this method. This is basically a typical heavy haul, have this drawing showing how to their weight, the COG, the module weight, and get the COG information. This slide is called smart weight control management process. Okay. When we got a weight process, like when we during the process, we have we called initial calculated weight. Okay, we are based on our weight and checked weight and density against the benchmark. Basically, we have a database or based on experience. And also at this stage, also we need assigned weight control engineer, technical lead. Okay, make sure we can assign the right person. And then we have the database for the weight to get all, for example, the equipment weight and some details, some fabrication weight or whatever we can collect at this stage. When we get all this review or module or the set of model review, so we can conduct a regular, the review, make sure all the discipline, give us the weight. So if we got all the information, for example, we're going to prepare, we call the weight report monthly, and all these the weight report, we're going to share, for example, with our bodyguard. We're going to have working with a different discipline, so make sure they agree or they understand what's the initial weight. When we move to the detailing engineering, we have to collect all the detailing, for example, the information. We have a lot of connection details, whatever, because different fabrication use different details. They can use the weight. At the beginning, definitely have some we have assumption, but at this stage, we're going to have a lot of detailed information related to this detailing the weight. We call it connection detailing or fabrication detailing weight. When we get the information, definitely going to have firm weight. Based on the firm weight, we're going to be share all the information to our subcontract, for example, shipping company. They're going to prepare all the shipping plan based on the weight. And also the hydro hall going to also prepare their transportation plan, okay? And also they can validate or the weight. When we get to the final weight, if the weight exceed or some limits, we're going to raise our flag to all the disciplines, especially for the motor yard or shipping company. Okay, they'll tell them, okay, if, for example, do we need change some plan, for example, shipping plan or any transportation plan due to this weight change. Okay, so if not, it's good. If we have to do it, but at this stage, we have to do it. So we have got a final weight, so this is ready to go for our job site for installation. This is basically our control management approach. Okay, as a Mode Smart, definitely we're going to commit to our client. Okay, so we're going to develop and execute successful integrated strategy for modularization. That means the maximum benefit to project schedule and reduce total investment cost. That means we are going to highlight the potential risk and provide variable solution during these all phases. That means we're going to review and report on module package by others. And also we're definitely going to provide commercial structure detailed to client requirements, including lump sum, unit rate, times and material, cost plus services, work package agreements with an open book estimate. Okay, thank you. If you have any question,
yeah.
Andy,
I've received.
And also we have here we have our website. If you need more information, you can go to our website called www.modesmart1.com. You can get more information about our company. Thank you.
Excellent. Andy G, thank you so much. We greatly appreciate it. I have received no questions via chat. We've asked them already. I like to open it up for a minute to the audience. If you have a question, please unmute, state your name and company, and ask Andy directly your question. If there are any last questions for Andy before we move to the next presentation. Andy, thanks for stepping up at the 11th hour. We greatly appreciate it. We valued the details that you shared on your topic. And look forward to working with you in the future to do that. Okay. What I like to do is go ahead, Andy. Any final comments?
No.
Okay.
Thank you, Andy.
Everybody, thank you, Andy. Greatly appreciate it.
Thank you.
Okay. I have received a couple questions. I put them on a PowerPoint earlier. I'm going to pull that PowerPoint up. We're going to move to the panel discussion with our co-chairs for modularization on CURT. And if Stephen Leu is on from Camorra, Stephen was asked to be added through Badar Alam from Camorra's as well. So we just give me a second to upload my PowerPoint and share my screen, and we'll move right into the last section, and then we'll do a wrap up. Okay, can you hear me okay? And Bill, if you can unmute. Alam, if you can unmute.
Yeah. Okay. Good.
If you can unmute. And Steve, are you online? I did not see Steve online. Is he with you, Bernard, at the office?
No, I'm at home. Steve did connect in. I think if you can just instruct him on how to unmute. Steve, if you scroll, you'll see on the bottom left-hand corner microphone, and if you click on that, you can unmute.
I'm there, Badar.
Okay.
I can hear y'all.
Okay.
Hopefully you can hear me.
Yes, we can. Okay, so we have all four online. So this is our panel where I have a couple of questions received. I'll ask those questions, and I have assigned one of the four of them the first response to the question. So hopefully they're going to be prepared. We'll see how this goes. And then I like to open up after each question a brief, allow the audience to chime in to comment, but let's try to keep it kind of crisp. And then we'll move on to the next question, and we'll proceed through the several questions that I received. Okay, the first question, what are the biggest challenges? My screen's blocking it. Sorry about that. I just move this for a minute. What are the biggest challenges that you are experiencing? Reference keys to modularization success. Bill, since you're the chair and you were the lead for the longest, I figure I'd put you on the spot.
Okay, not a problem. You know, and for me, this is still fairly easy. And I think we've seen earlier from our FMI report is the mindsets and cultures. We're still making a lot of headways, but getting people on the project teams to think modular and think lean is still an issue. We're doing a lot better, but with multiple project teams, globally, getting that strategy built into our process to where everybody, considers some form of modularization. I used to always say that there's no project I've been involved with where I had zero modularization, but also there's no project where I had 100% modularization. So just getting people to open up and think about it early enough that you can have an advantage.
I like to open it up for the rest of the panel. If Badar or Mike or Steve, if you'd like to build upon Bill's comment, that would be greatly appreciated. And I can go to Badar first. Any comments, yes or no?
No, I think that, my experience, and again, hopefully Steve can speak to this, is fully aligned with what Bill is saying. For me, it's as much a mindset, level of experience, capability based than it is, sort of methodology and the technical elements, right? So if we can get people thinking and understanding what modularization is, and I think we spoke about this a little bit yesterday during a conference. Oftentimes, and a lot of the presentations we've seen, we think about really large modules, right? But a lot of the kind of work that we're doing in our existing plants are smaller assets that are being integrated into operating units, and there's still an opportunity for on-site fabrication, pre-assembly that are part of that modularization scope. And so if we can get our team members and resources that historically haven't thought about that in that way, moving that way, we can make a significant impact.
Okay. Let's stay with Chemours. Steve, any additions or adds?
Yeah, I agree what Bill and Bedar both said, and Bill and I go back a long ways, and one of our biggest items that we went up against, the biggest obstacle, was convincing project team leaders and the design group that this is a good idea, this will work, this can work. And we've struggled with that for the past 25 years. I mean, we all understand it, this group here, and a lot of people it's catching on, but it was really tough to break that ice. And we still run up against that hurdle some. And now Bedar is in a position, and he's put together an internal team with Chemours to where it's a checklist of basically it boils down to why would you not use a module concept, modular, or the SAS that we use. So it's made strides here in the last year from our perspective here, but we struggled for years of how to get that across to people and the benefits from it, and we'd list them. And that's, I think, pretty much across the country, the industry, it's the same thing. There's this hesitancy like, oh, it's going to cost more engineering, it's going to cost more material, I'm going to have transportation. And in some cases, you might have a trade-off where it might be a little more engineering and it might cost more to get it there, but the benefit of the cycle time of getting that project complete in a shorter time and getting that product on the market, when you weigh that all in, it can really offset the cost of what it might have cost you. Sometimes it's cost neutral and sometimes it's even less cost. So, you know, till you get metrics and numbers in front of people, they won't all totally be sold on it. There'll always be some negative thought in the process, but we all know it's really a good idea, and most of the country seems like is catching on. The industry is turning into a big selling point. So I think it's finally got to that point where it's not quite as hard to sell anymore as what it used to be. I used to feel like a salesman. Bill and I sit in on some early projects, and it was like we was trying to sell Avon or something to the like.
I think we all have. Gotta get the cars, I guess. There you go. Mike, last but not least, I'd like to give Mike the opportunity to share any additional ads. Mike Brewer.
Sure. Not a lot different to add. I did like your comment about the sales approach. I was thinking similar, that it felt like I was on a 3-year adventure trying to convince people to even take a look at it and give me a few engineering hours to look at the benefits. And when we finally got ready to rock and roll, then COVID hit, and so we're looking at another year or two before we can do anything really serious with. And we do some offsite fabrication, and I think most people do with e-rooms and other things, but to bite off the big one, it's tough to do. And project size is growing. Most of the projects are turning into mega projects these days. So you've got the executive board, the board of directors, very interested in what you're doing with that money, and potentially putting maybe not the whole company at risk, but some serious opportunity to hurt business units or whatever if things don't go right. So when you don't have that groundswell of experience in that, it's an uphill battle. But I was encouraged by Sabine's numbers and charts showing that there is a groundswell. It may be a fairly slow groundswell, but it is moving in the right direction. So encouraged by that. That's my comment.
Excellent. Boy, you guys brought back some memories. This was an Italian doing an Irish dance on the table back in the days when I had to do it. So, and I didn't call it the Irish, never mind. I got to be politically correct nowadays, but the Italian. What I'd like to do is, if you look at where modularization committee's been, 3 years ago, we did modularization 101. This is modularization. This is what we're about. Last year, we moved in the truck shippables and the focus of truck shippables. This year, what was asked from the CURT members and CII members was looking at the roadmap to success and going into that details of the 10 key elements, the details of center of gravity, the details of quality assurance and control, the details that you've heard today. So we've done the deep dive today, I would say, but what are you experiencing? And this is to the audience. If anybody likes to chime in, unmute, state your name, and that what we would value as a committee leaders of CURT for modularization is, what are those biggest challenges that you're experiencing today? What are you seeing today, and what do you want to hear from this committee tomorrow, say? And if anybody has any input, we'd love a crisp viewpoint of what your perspective is, if you could. I'm going to turn it to the floor. Anybody, please unmute, state your name, and let's see if we can see you. A lot of shy people, or everybody's muted and can't get off of mute. Okay. If you have input and you do not want to share to the audience we have, please feel free to send it to any of us. Bill, I'll get it right. Adam, yeah, I'm sorry. I'm just getting tired today. It's been 3 days of long virtual meetings. And Steve and myself, or any of the CURT leaders, any input would be valued to this question as we get ready to plan for next year. What I'd like to do is move to the next question that we received. How and when is modularization built into your project execution strategy? I believe we talked a lot about this today, but let's see if we could just summarize it real quick here. And Mike, I put you can't get away for free, so I got to get you. I'm going to direct the question to you since you were last on the last one. How's that?
That's fine. And yeah, I think I wouldn't say we beat it to death, but obviously unanimous consent that it's early. You've got to do the groundwork even earlier than that, as we all know, to get consensus and build it into some early engineering, feed engineering, whatever strategy time frame. And get most of the bigger engineers, whether it's Fluor, Bechtel, you know, the laundry list of the bigger engineering companies have full modular groups, departments, functions, so they can be tapped into. Some of this they'll do freeze a bad word, but some of it they'll come and take a look and give you a 40,000 foot level. To maybe bring in some of the doubters or naysayers, but that's the only way you can do it. If you're half done and you start, you may end up with a disaster. So that's, you know, that and just builds from our first biggest challenges, and that's that there's still that groundswell that or wave that you're fighting against to get people on board. So I'll let the rest of the group add on to that.
Okay. Hey, Steve, 44 years, I believe, if I remember right from last year. What's your perspective? And I got Siri answering the question here. Sorry about that.
Well, like Mike said, the earlier the better. The front end loading stage is when we go through that, like the checklist that Badar mentioned that he started with internally. Here with Chemours, you've got to know your strategy, and if you're in the front end loading and know what the concept is, I mean, if we got it on a PDMS model, the concept's pretty plain. We can tell right away if it's a modular concept or if we've got any opportunity to do it. And like I say, schedule builds into it. It's just a lot of variables, but we have to do it in front end loading 1 or 2, usually 1. And that's our best chance at doing it, of making it successful. And right there's where you have to sell it.
Okay. Badar, Bill, I turn it back to you two. Any final comments on this question?
Yeah, I guess just to build on what Steve was saying, you know, what we've tried to do now is drive those strategic decisions and that high level thought early. And similar to, you know, how the design progresses from FEL1 to FEL2 to FEL3 and into detailed design, we want the modularization effort to sort of parallel that. And so the strategy comes very early, and alignment and objectives around the modularization are put together ideally in FEL1, and then as we go into FEL2 and FEL3, we build details and specifics and strategies and approaches, and then make sure our design reflects those. So it's start early, but evolve consistent with the sort of the overall design development process.
Yeah, I was going to say what we've done, in the last couple of years is we've bought into this a lot more than we had in the past, and we've actually went back into our early FEL planning, our site selection, and made modularization, an integral part of those selections. Our greenfield projects, we're doing a lot better job with getting engaged early and developing a strategy. Or the existing sites that are operating, where we have the small capital projects and stuff, we're trying to make roads into that, but we still got some work to do there.
I like to build on it based on my past experience. Back in 2010, when I was leading a lot of this back in an owner company, one of the things we really needed to do is, it wasn't only the engineering execution strategy, but we really bumped it up to where the funding avenue was, and we worked with the business sector or business arm of the business to ask the question, how much modularization are we wanting to pursue or willing to pursue early on in the project execution? And bringing the business involved in that brought alignment way up front, early on, even ahead of that FEL, but it was in that early preliminary funding of looking at what do we need to do the project and showing the advantages of where money could be shifted or schedule could be advanced. I just want to share that as strategy is very, very important in this leg of modularization, to get it on the ground and get it into standardization too in a footprint if you have that opportunity. Okay. Any questions from the audience or statements on this one?
I do. Can you hear me?
Yes. Can you introduce your name and company?
Yeah, this is Scott Clements with Figro. And this is more intended to Bill. In regards to dimensional control, are y'all currently developing or getting a dimensional control, to technically develop workflows and specs early on in the process? Because, normally we come in during, right before construction, and we've been on your, the lead DC surveyor on your Gorgon project, and, most recently the GCGV project. We're working with CTCI and Return International. I just wanted to hear your thoughts about that.
It's interesting because if you go back years ago, and even some of the modular yards now, we have all these total scans, these laser tools, so some of my past projects, one of the things we've done was scan the civil work, scan the modular yard, scan the vendors, pull all this together into our module or our model and see where we had busts. Now, I had a friend that actually worked on the Sasol projects recently, and they brought 72 modules in, mainly pipe racks, and all 72, and they used total scan, fit like a glove. He said they had no issues. Weld fit ups was almost perfect. And we're just doing a lot better with that. Actually, some of the modular yards still use a plumb bob, and a tape line, and even with that, we're seeing very few. I think that we've put enough quality steps in, where that validation is much better than it used to be. I think it's critical, and people are recognizing that.
I totally agree with you, and just like it's good enough for China philosophy, it's just not up to par with European standards, and a lot of it. We're constantly seeing it get better and better as we move forward.
Yeah.
Thank you for that question. I appreciate it. Any last questions from the audience before I move on to the next question? Okay. Engagement's a real critical part that we heard yesterday in meetings and the day before, and it's a global engagement type of question is, what resource staffing needs have you found to be successful in supporting your modularization strategy? And again, this is a keys to modularization success. And I'd like to go ahead and start with you, Badar, if I may.
Sure. Thanks, Joe. I guess from my perspective, it's probably two dimensions in terms of the resources and staffing. One is the construction engagement. I think we talked, when the IPA presentation yesterday at the members meeting, they highlighted all the key roles, including project management, project controls, and construction. And one of the subtleties that they brought forward is, hey, proactive construction engagement. And I think that's really essential, because the construction resources are the ones that have, the task and the accountability of putting that asset into its final installed location and finding the most efficient and effective way to do that. So getting those resources involved early, having them be educated, qualified, having the right mindset to be able to think and orient themselves around modularization versus going to a traditional stick-built approach. And I guess the second part of that staffing model, and I think, again, we've talked and we've spoken about it. I know I spoke with Bill and certainly recognize Steve for this, but it's experience and energy, right? So one of the key resources, and that's why I invited Steve onto the call for us, that I think is a key enabler for our success in our organization, is Steve Lehue and people like Steve that have been in the field, have been working and experiencing both the goods and the bads for many years, and through that practical knowledge, experience, through the successes and the heartaches, have learned what works, how to think about it, and bringing those people in and using them to amplify the voice around modularization or on-site, sort of pre-assembly, and educating the broader construction organization that we have, I think are really keys in terms of supporting our strategy going forward. So getting our construction resources involved up early and bringing some reinforcement to them and some ability to see a different level of experience than they have had are the two key points I'd bring forward, Joe.
Badar, thank you. Steve, he's put you on the spot. Do you have any comments?
Yeah, I do. Experience is very important, I think, but in today's world, we have so many electronic technology. I mean, when I think of PDMS modeling, the 3D modeling, we went from Microsoft, we went from drafting to drafting tables to this. We have the Kleischer on the modeling. We went to photogrammetry. We had laser scan. You add all this up, throw the experience in with it. I mean, it's like the best of both worlds. It's almost like, how could you fail with this concept when you got all those key benefits to use in alignment with it? So it's just, to me, a no-brainer. Why would we not use it? And with all the experience and everything that we got at our fingertips now. And I wanted to clarify one other thing. I think it's a myth out there that we got to have a greenfield project to make this work or for modularization to be a success. We have done so many retrofits, and most of the work that we've done is all retrofit. So when you can do it retrofit or greenfield, it's got so much more value to it. And we've branched that out to where it's, personally here, we've been associated with 800 lifts, and almost all of them, the biggest share of them have been retrofits. So it's got so much, but you got to add all those factors together, and then you come out with a successful recipe.
Steve, I don't know if you have more gray hair than me or if I have more than you. I can't see your picture, but great answer. That's really good. Now, Bill, I can't comment, so I'm not going to. I can call you Jack Nicholson, but I can't say anything about your hair.
I better get my hat on.
Okay. Back to you, Bill.
Yeah, no, I agree. One of the things that and this group realizes it more than anyone, is we've lost a lot of our you know, our subject matter experts. And we have been leaning, you know, I can, and it's just not from an owner side, it's also from an EPC side. There's been a lot of turnover of the people that's done this. So like everything else we're seeing in workforce development is, you know, renewing the competency, is we've not done a very good job of that. And we're struggling a little bit with that. But I have to tell a story. Last Christmas, I called one of my old colleagues to wish him Merry Christmas. His wife answered the phone, and she went to get him. When he picked the phone up, he knew it was me, and he said, "I'm 77. I'm not working anymore." so I think I wore my welcome out there. But we've leaned on all that expertise, and we've not captured it well enough. And hopefully we're doing better now.
Rest of the panel, any final comments on this question?
I just had one small one to add, and I keep muting. The dogs are going crazy for some reason, but we're looking at it as like a project team within the project team. So going through the execution planning, looking at every function, whether it's project management, engineering, procurement, logistics, even controls and scheduling, and the construction interface that was mentioned. I think you have to look at where that expertise is. It might be an owner's team, it might be an engineer, it might be a mod yard person, it might be a third party, but you don't want to overlook that when you're doing all that early planning.
Excellent. Must be lunchtime for those dogs, but you have to wait for one more question. I have received one more question, and it is, we already talked some of this. Steve, do you have a quick answer to this one? And I do have another one I think is an important one we should ask, but I don't want to cut this one short. Steve, do you care to build on this one at all?
Yeah, there again, on the early concept, FEL, if you know you're going to use modularization, you need a rigging plan, because a lot of times if it's a shipped in module, you're going to have transportation, a loading, gold hoppers, whatever it takes. So the rigging plan could be a crawler. It could be a large crane that you bring in to set all the modules at once. It could be field assembled. You need a small crane or a carry deck, and then you schedule the big crane. So you need to know up front how you're going to do it. And if you got room to put the crane in there, maybe 2 cranes for one lift. It may be multiple cranes. So it's all about the plot plan, front end loading, know what all you've got going in there, how much real estate, how much space. And then you have a sequence, what you build first, second, third, and which module goes where. And then coordinating the shipping to where you get module 1 shipped first and not module 12 shipped first. So it all dials into the front end loading.
Excellent. That's a great answer. And I know we covered a lot of those details with Andy G and some of the other topics that we heard today from Georgiev and all that. Again, panel, any additions beyond Steve? And I'd like to go on to some of the next question or two if we could.
Good.
I see heads nodding up and down, you're mute, so I'm going to go to the next question. Can maybe 2 of you share, and I got Bill and all is, but maybe Bill and Mike, can you share, based on your experiences, some of those high-risk learnings that you've seen in your career in reference to modularization? Bill, you first.
Yeah, I think the first thing to come to my mind, we talked about a little bit, the actual transportation logistics and the value for getting people from a construction standpoint and from, you know, the logistics engaged early. Like, and I'm thinking when you get it with ships and barges, you need to get that marine surveyor in there and get them involved. And, you know, if you miss some of these things up front, it's very hard to go back, you know, and correct. If you don't get your weight balance out in the beginning, if you don't understand what ship or what barge, the way they do the ballasting, you know, what trucks you're using, and, you know, all the permitting requirements and stuff, then you're going to have some rude awakenings of some bad days.
Mike, any build?
I'd probably just say that it took us a long time to learn. I don't know if we've totally learned yet that we keep being the early, but not just early, but thorough and right. Whether it's the 4 Ps, the 5 Ps, the 6 Ps, proper early planning. And time again, you say, oh man, if we'd have done that 6 months ago, or if we'd have thought about that or whatever. There's a myriad of checklist, help lists. Everybody's got books on the, journals in the shelves that give you all the execution planning questions, and don't forget about this area. And again, it's across every function. And I think most people have those, but you can get them out and make sure they're used and have thorough plans.
Badar, I know you're diving into this right now in real life with Chemours. Perspective to share, or what are you experiencing as you dive into all of this?
Yeah, I think from my perspective, Bill, the real high risk items is meshing sort of the business needs drivers with the execution, right? Is aligning and making sure that when we think about all of the parameters that are going to be business critical, whether that's cost, schedule, quality, safety, and we've covered all of those areas today. Really understanding those and then aligning those and making sure we got risk mitigation measures around, the elements that could influence any one of those 4 dimensions, and getting a strategy and a risk mitigation measure. I think there's a tool that CII has developed. I think it's called critical success factors for modularization, and I think there's 21 of them. And I think if we can again proactively have, like Mike was saying, there's a lot of lists, but I think that's a really good list. It's 21 straightforward factors, and if we can look at those critical success factors, they really align with and drive towards helping us manage those high risk items.
Okay. What I like to do is this is our last question, and I like to open it up to the audience. And as the audience is chiming in, if you could state your name in that and share any of your experiences. I am going to switch PowerPoints. We're down to 4 minutes. I need a minute to switch over, and I will end us on time. So audience, any questions while I switch off?
Hey, Joe, I see where I've seen that John Stevens is on there and Russell White and some other of our colleagues we've worked with. I would just like to hear quickly from them what we could do to make them more successful in their modularization strategy. And we as owners, what can we do to support them? You want to answer that first, John?
Yeah, I think I can, because it goes back to the I think the FMI presentation earlier. You wanted to know how to make modularization occur more often, and the one thought that I had is that maybe CURT needs to include what is a contractor's commitment to modularization when they're having their third-party companies that evaluate contractors. Maybe that needs to be a question that's asked. What is a contractor's commitment? And off-site to me is prefabrication of piping. It's in some cases structural. It can be putting it all together, the testing. So there's a lot that it could be. We don't dabble in the mega modules. You guys know that, but in the truck shippable areas, having a commitment by the owners to wanting to use contractors that embrace and want to execute projects. I think that's one of the things that I think is important.
Okay, thanks, John.
Thanks, John. Appreciate that.
Yep.
Bill, who is the other person, or did you?
I seen Russell's on here. Are you still here there, Russell? Russell White?
Absolutely.
Yeah, but, I was just thinking of you guys as owners. What can we do to help you become more successful?
Well, I think one of the comments I wanted to make earlier is just that, and this is obviously not just modular, but just continue to get construction involved upstream as much as possible. I know, you know, depending on who's engineering, whether it's owner engineering, whether it's an EPC, there is still a tendency to throw the package over the fence late in the game on some of these modular packages where we have to understand our scope. And it's obvious that it's not as intense as a stick build, and it's pretty standard where you're doing interconnecting, you're doing your civil work, that kind of thing. But it sure helps us to get involved in the process more upstream. And I know it might be a little bit more difficult with a lot of the international firms, which seem to be more prevalent recently. But we certainly have been active and seen a lot more modular projects. And we look forward to being more involved upstream in those planning sessions.
Okay, Bill, you took my 2 minutes, but that's good.
I know I put you behind schedule.
No, we'll be 2 minutes over now. I'm gonna bring it to recap, but let's take a quick look at the past. 3 years ago, Modularization Committee, Task Force, into committee with CURT, Introduction 101, Modularization. Last year, we moved into truck shippable, really focused on the smaller modules, the smaller data, the FMI studies, both on contractor and owner. We've carried it forward this year with FMI providing the forecast and the trends of today that they were seeing and what we saw. We talked about our northern partner up in Canada with module assembly. People wanted to know that 10 key element journey, and we went into a deep dive on that one there. We took the time, we took the quality time to share that deep dive. Shifted into a modular versus stick built comparison. We talked about quality assurance and control. We talked about design, early design, center of gravity, weight balancing and planning. And then we talked about, again, through this panel, all those designs and information that we shared. As we move forward, we want to hear from you over the next few months, maybe the coffee hour that's going to be coming up in CURT with the CURT Connect with this team, and we can talk some more about what is your barriers, what are your barriers, what's important to you, and where do you want to take this committee into 2021 as we move forward with everything going on. So that's value to everybody that's showing up on the screen here from the board and all that. What I like to do is take a moment to really congratulate Mike Brewer. He received an award with CURT in appreciation of an outstanding service and destination of the Construction Users Roundtable. Mike, outstanding. We wish you all the best on your next endeavors, and we'll see you back in the future, I know, but we want to wish you all the best. We can see all the toys behind you, Mike, right now. So we know where your focus is. So enjoy the family and enjoy what you're doing out in Arizona. Stay cool and enjoy these new residential contractors that you're going to be dealing with. It is different. I can tell you that as a real fact from my side of the business. So residential is totally different. Mike, congratulations.
Thanks. And definitely regressing, going back to my childhood, so I can just turn around right now and have at it. So
there you go.
Much appreciated.
Have a great time. Okay. Most important, thank you to all of you that attended today. We had a great show, turn-in, and wish we had a little bit better interaction, but it wasn't your fault. It's just the way the presentations were presentations today, and we're all learning from that. But thank you to all of our audience. Hopefully you gathered value to bring back to you and your company in doing that. So thank you to all of you. Appreciate that.
And Joe, all the presentations are available online, or?
Yeah. All the presentations are already posted on the CURT app. We have a recording link that'll be going out to all that have attended today to be able to call up any of the actual presentations and questions and answers and things that we asked. Again, to our chairs, Bill, Badar coming on board, Mike, all the best in the future. the team of presenters that we've had here today with their pictures showing. Thank you so much. We really appreciate that. Again, last but not least, our CURT staff, all behind the scenes today making this happen. Monday was the test when Zoom went out. This team stepped up, and you should have saw the dynamics here in the office. We started on time, ended on time. We started on time today. We ended 2 minutes over because of Bill, but it's okay, Bill. I forgive you. And I want to thank the CURT staff for everything that they're doing all the time here behind the scenes. Last but not least, thank you. I look forward to seeing you all at a future event. It's been a great day. I've lost my voice, so it must be successful. And thank you, and I wish you fair due. That's all, folks.
Thank you.
Have a great one, and great seeing you.
Thanks. Take care.
Thanks, everybody. And if you're
Bye-bye.
in
Have a good day.
the Gulf Coast here, be careful.
Yeah, be safe.
Okay. Yeah, be safe and healthy, everybody.
Okay, great.
Take care.
Thanks for hosting, Joe.
See y'all.
Bye.